Good morning, class. Today we'll have a small session by Advait Pura. Right, what I thought of yesterday, I kept a very small introductory session with what is FEA, and I'll say how we can do a small structure analysis. So Uday has explained us the small example of the pulley, how we can do a structure analysis, and at the same time he talked about the FMEA, like what is the importance of the FMEA, failure mode effective analysis. Now, whenever we talk about the analysis, in especially in mechanical, we have two types of analysis which are very important. The one is called as a structural, and another is called as a plastic flow, or you can say a fluid flow analysis, right? So Uday yesterday talked about the structural analysis, right? And today we have Advait with us, right? He is also our alumni who has published a very good paper with related to plastic flow. Okay, and at the same time he has developed a small mathematical equations also. So I hope you will enjoy this session. You may ask him lots of question. Okay, Advait, at the same time I just want to inform you that these students are third year mechanical students, and related to the simulation part, right, we have not started yet anything related to simulation.
Okay, sir.
Just a theory first module we have completed. If you remember, you were also the part of the FEA only, but as an elective. So in first module, there was just a basic about what is FEA, advantage, disadvantage, and the weighted residual technique.
Right.
And yesterday, even I talk about little bit about the topology that we use for FEA, like what is node, what is element. Okay, little bit,
Right.
just a basic I have started. Okay, so I hope you will go from the very scratch basic, so it will be very easy for them to understand.
Absolutely.
Okay. Yeah, thank you. The session is for you, Advait. Please
Thank you,
continue.
sir.
Yeah.
Yes. A very good morning to everyone. I am Advait Purav, and as Hitendra sir told, from the same college as yours, and I just graduated this year. It's my privilege to actually share some of my knowledge and the research that I have done in my paper with you all. And this, don't worry at all. This will really be an interactive session. It will be an interesting session where I hope no one sleeps and we actually interact with each other with all the things that we want to share and the knowledge we want to impart with each other. So let's get started off. So this particular lecture will comprise mainly of finite element analysis, also the simulation part on how you can FEA is used in simulations everywhere in like the softwares like SolidWorks Plastics especially. And it will also consist of some of the rapid prototyping techniques like which use like 3D printing, direct metal laser sintering, and the other methods which through which I have in through which I have like done my research in my research paper. So let's get started off. So yeah, guys, so you have like been introduced to FEA just right now. So on your basic knowledge, what do you think FEA is? Amongst these 6 points, what do you think FEA is? Is it a graphics tool to make attractive pictures? Or is it an example of garbage in, garbage out kind of a model? Or a powerful stress analysis tool? Or a mechanical tool for mathematical tool, sorry, for solving the boundary value problems? Or is it trying to find the exact accurate solution? Or is it all of the above? Like you may unmute yourself and let me know what you feel the right option should be, or you may type it in the chat so that we can like really understand what you know about it and what is your interpretation of whatever you have learned up till now. So just see the chat box if anybody is answering. Or
Advait, don't worry. I'll tell you. If anyone write in chat box, no,
okay,
I'll
okay,
inform you.
sir.
Yeah.
Sure, sir.
All the above.
Yes, what's your name, bro?
Atharva Belnegar.
Okay, yeah. Yes, your answer is right. Okay. Uh, Anybody else has some other answers, or who would like to contradict Atharva's answer? And Atharva, can you like tell me a little in brief why do you think it is all of the above?
As you know, like it deals with like small things that you mentioned in the options. Like it deals with the graphic tools also. Also, we get to know the boundary conditions of like what we are up to something. So
Right.
from that boundary conditions, we can like interpret the result very well and like efficiently. Yeah. So yeah,
Okay.
all the points like yeah,
Hmm.
yes.
Okay. Okay. Good. Good. And anybody else has any other answers? Like if you want to point out or
I am Umair, and I did not understand like why the first 2 points can be included in this.
okay. Okay. I'll come back to
Just a
you.
second, Advait. I'm sorry to interrupt you in between.
Sure, sir.
Umair, he
Yes,
asked
sir.
one answer out of this. Okay, what you are
Okay.
asking him is something different. But still, let me give you answer when you ask it. Sorry to interrupt you, Advait, in between.
Sure, sir.
The thing is a graphic tool to make the attractive picture, yes, because when we see the results, it gives the graphics. So that's why he has included with his experience. And second one example, garbage in, garbage out. Many time what happen, no, people want to prove their point. So what they do is, like example, suppose I am a constructor manager, right, and I want to say the municipal people that yeah, whatever building construction or the structure I have submitted to you, it is correct, right? Whether it is correct, right or wrong, what they will do is they will make a structure, and based on their requirement they will try to prove in FEA by doing some kind of misarrangement, or you can say some kind of settings. So that's why he has included these 2 points. That's the thing.
Okay, sir.
I hope
Understand.
it's clear. Yeah, thanks.
Yes, yes,
Sorry,
right,
Advait,
sir.
please continue.
Absolutely right, sir. And I would like to elaborate on the point that sir told as well. But anybody else has any other answers? Any interesting points to quote, or anything to tell? Um, okay, so I will just elaborate to you all these points about, and even Atharva, like whatever you told, what was absolutely correct. That it is a, it is a, it consists of all these 5 points, the first 5 points in their own ways, like a graphics tool to make attractive pictures. Absolutely, like finite element analysis, like it is used absolutely everywhere in simulations and carrying out simulations, and the ANSYS software or other modeling softwares, in order to like find out the stress strain result, or to find out the the particular flow simulations or thermal simulations, or how the particular part is behaving in a particular environment. It is it helps you to give that sort of amazing attractive pictures, which you can really put up in any kind of a business meeting, and you can make your beautify your presentation. An example of garbage in, garbage out. So this particular statement is like applicable, it is open to all kind of interpretations, like whatever you input, like garbage is just like a kind of a like funny kind of a uh, acronym kind of put in this, but you can interpret it like you put your input parameters and you get the output. So you basically put in all your input parameters, such as the boundary conditions, your force, your other things, like um, and whatever you want to put, and you get the output result out, which is the deformation or the stress that you want to calculate, the factor of safety, etc. A powerful stress analysis tool, absolutely. Like stress analysis, like if suppose I'm applying a force on a particular beam at and my and I want to find out the stress um, which is like you know dis- displaced throughout the particular beam, or which is present. I want to see the stress at each and every part or node of the that particular beam, which is this particular thing is not possible in the practical world, where you can actually simulate it. But because of the FEA, we are able to really do this so easily, and it is an excellent you know uh, innovation, and a you know invention of, which is the hard work of all the engineers as well as mathematicians. A mathematical tool for solving the boundary value problems, absolutely. Like you input the boundary conditions in it, and with the help of mathematics, you have your partial differential equations to solve at each and every element, and then you compute the outputs that you want. So it consists of both hardware as well as software. It's not just one particular, software which is going on. It is a combination of both hardware as well as software, trying to find out the exact accurate solution. Now here, FEA or any kind of software, whatever we calculate, whatever outputs that we calculate, we never find out the exact solution. We always find out the approximate solution, which is nearly closer to the exact solution. Like in engineering world, sometimes the tolerance or the approximations of some 1 micron or 10 raised to minus 3 is also quite a good result, because it is quite closer to the actual or the exact solution or the exact value that we want to find out. So it definitely consists of all the above points, and so your answers are absolutely right. Yes. So we'll move on. So this is a particular thing. What is FE in a nutshell? How do you go about? Which is, I'll just explain to you in very brief. Suppose you take any kind of intricate part, whether it is, now in this case I've taken a spring or maybe a beam. Okay. You want to find out the stresses induced in it, or the deformation or deformation in the spring, or the stresses induced in it at the various points, or at the various elements. How will you do that? You cannot do this practically by testing it on some kind of a measurement machine, the stress measurement machine or whatever. Like, you cannot do it. It has to, if you want to find out the stresses or the deformation at each and every part on the spring, you need to use this particular finite element analysis. So uh, how have these particular people designed this FEA? Is that they divided that it made it in such a way that you have to divide that particular part into finite number of elements, which will consist of elements as well as nodes. Like elements will be separated by boundary layers, and and each will consist of a number of nodes. Then you have to simplify each particular piece. Now in this case, suppose I'm applying a force from in the y direction. Sorry, from the top. If you can see, so here it is in the Z, from the top. So it will deform to a certain extent, and its equation or the relationship between force and deformation can be given as F is equal to K into D. K is the stiffness matrix, and the stiffness for each particular spring or that particular element can be is actually, you know that particular value. And in order to find out the deformation, you will have to just take the inverse of the stiffness matrix, and you will be able to compute the deformation at that particular element or throughout the spring. Reassemble and solve the problems, matrix formation as well as manipulation. So the stiffness matrix will be in the form of a matrix, will be in a 3 by 3 or whatever 4 by 4 matrix, and you will have to find out the deformation at each particular node or element through this particular equation. So this you will as you go on studying this particular subject, you will be able to solve a lot of differential equations, a lot of problems which involve matrix multiplication and manipulation. So you will come to know about this as you go on studying it. Now, so I've just exaggerated this particular word and meshing, because this is one of the most important part in FEA. Basically, FEA, as I told you, it consists of dividing that particular domain into finite number of elements. So it basically consists of breaking that geometric space into a number of elements, so that you can compute that particular result on those particular finite elements, and you can get the values throughout the domain. So meshing influences the accuracy, convergence, as well as the speed of simulation. Definitely. The finer the mesh is, the more accurate your result will be. And the more coarser the mesh is, the more approximate or less accurate your result will be. Partial differential equations are solved on these finite elements or shapes, as I mentioned it earlier. So meshing is one of the most important aspects in FEA. So this is as you can see, this particular mesh is a coarser mesh as well as this is a finer mesh. Coarser mesh will give you a more approximate result or a less accurate result, whereas a finer mesh will give you a more accurate result. However, a finer mesh with more number of elements will increase your computational cost. Computational cost क्या होता है कि आपका the cost required to evaluate the result or the time that is required to evaluate the result will be quite high and it will be more expensive. So you'll have to maintain a balance between your computational cost as well as accuracy. So now the important types of mesh. So there are actually in this is with respect to a little bit of simulation, what we do in ANSYS or what we do in other kind of FEA softwares like maybe SolidWorks Plastics or SolidWorks Simulation. So in that you come across these terms. What is shell mesh, surface mesh, solid mesh? So what are these exactly? So basically, a shell mesh is a mesh which is a 2D mesh, which consists of two things: triangular or quadrilateral mesh. So in that, those meshes are not in the x, y, and z direction. It's just in the x and y, and like you, uh, in this particular thing, the computational cost is quite low. Like if you go for a shell mesh, so the accuracy of the result that you want won't be very high, but it your result will be evaluated quite faster because क्या है कि shell mesh है तो इतना वो बड़ा नहीं है, like सिर्फ it just is in the x and y direction, so you can like easily calculate the result quickly. And what is a surface mesh? Surface mesh is the mesh on the surface of that particular domain or that part, and it consists of all the meshing on the boundaries, the vertices, as well as surfaces. And after the surface mesh, you go for a 3D mesh or a solid mesh. Solid mesh consists of the mesh in your entire like x and x, y, and z direction, and it consists of a lot of like these elements like tetrahedral meshing, pyramidal meshing, triangular prismatic meshing, or a hexahedral meshing. So if you can see these images, this is a particular example of a tetrahedral mesh. If you can see very closely, this particular meshing involves all the tetrahedrons which are packed into one another, and they help you to this is one of the most commonly used kind of meshing in all kinds of simulation softwares. As well, this is a hexahedral meshing, which consists of these square or rectangular layers which are packed into each other, consisting of finite elements. Hexahedral meshing gives you one of the most accurate results, and it's one of the best meshing for obtaining the most exact result. But however, its computational cost is quite high, so you'll have to so generally tetrahedral meshing is more commonly used as compared to hexahedral. Yes. So
Hello, I have a
yes,
doubt on
yes.
this.
Oh yes,
In
yes.
the hexahedral, it is like a square or rectangle, right? So in a tetrahedral meshing, it is a triangle. So won't it be better? Like the meshing will be a little smaller than the rectangle, right? So
In
won't
the
tetrahedral be better?
in the tetrahedral mesh, you are saying that in tetrahedral the meshing will be better. Is
Yeah,
that your
yeah, yeah.
question?
In the lower figure, the tetrahedral and
Yeah,
hexahedral. So in the right one, it is all are squares, but in the left one all are triangles. So left
yeah.
is much better while solving.
Actually, bro, this particular meshing, na, it also depends on the type of part that you are using or the domain or that surface. For example, for more kind of like intricate parts, generally tetrahedral meshing is used because उसमें क्या होता है कि you can for the intricate parts you can your if you want to calculate your result like for a particular part which is having a lot of complex features or like surfaces or like edges, curved edges, and intricacies. So in that tetrahedral meshing is better because uh, it will help you to find out the solution like more quickly as well as accurately. However, in hexahedral, thoda it thoda wo it cannot conform to all kinds of parts or domains in hexahedral. So like उसका इसका computational cost भी ज़्यादा आता है hexahedral meshing का and cannot suit all kinds of parts. So actually your kind of meshing depends upon the part that you are using or you want to perform the simulation on, and it mainly depends upon the designer, like on which kind of meshing he wants to use, or the simulation engineer. It's a collaboration between the two on the what kind of meshing they would like to use actually. So it is generally dependent on the designer and the simulation engineer, like, and on the part, like what they are using. So it's like that. But I'll come to, yeah, I'll even come to that simulation ahead, which SolidWorks plastic, which on which I've done the tetrahedral meshing, so you'll be able to understand it better.
Hello. Hello, Adil.
Yes, yes.
Yeah, I have a doubt. Can you please give me an example where we can use surface mesh?
Yes, surface meshing. So I'll give you an example of the things that I had done with respect to my research paper. So basically in surface mesh, surface mesh and solid mesh actually go together, okay? So in cooling analysis and injection molding, I don't know if you have heard about these injection molding simulation softwares like SolidWorks Plastics or Autodesk Mold Flow, but these are basically simulation softwares which I will show you further. They are simulation softwares in which you are able to simulate the entire injection molding process together. So अभी इंजेक्शन मोल्डिंग में क्या होता है ब्रो कि कूलिंग होता है कूलिंग. सो उसमें कूलिंग चैनल्स देना पड़ता है पार्ट को कूल करने के लिए इफेक्टिवली. तो उसमें you need to use a particular solid mesh or a 3D mesh, and before that you need to surface mesh that part so that all its boundaries, vertices and edges are meshed together properly, and then further this 3D meshing is done, which may be consisting of tetrahedral or hexahedral meshing, so that you get that particular that uniform 3D meshing domain, so that you can perform that cooling very effectively. So in cooling, it's in order to design any kind of like cooling channels in injection molding or while simulating that particular process that is used.
Yes, I got the answer. Thanks.
Yes, sure. As we go ahead, you will understand it better as we go on the simulation thing. Okay. Yes.
Advait, sorry to
Hello.
interrupt. People, if you have question, please write on pages. At the end, you ask, because sometimes it may happen that you are asking something, and Advait may have planned for that, in next slide or maybe on next slide. So please try it, like once he complete his PPT, then you may ask the question. Is it okay, Advait? I think that will
Yes,
be better,
sir.
right?
Yes, sir. Actually, even if they ask it right away, it's also fine, because because if I'm like into that particular topic now, then asking that question at that particular time is also absolutely fine. So no
All
problem.
right, no problem. Then it's no
If
problem.
you have,
Yeah.
if you have too many questions at a time, like 3-4 questions, then you may ask. You can keep some questions later. But if you
Okay.
have like
I
instantaneous
think
stuff,
Digant have one question. Yeah, Digant, you can ask.
yes,
Yeah.
sure.
Sir, I had a doubt that if the pyramid is of triangular structure, then
Yeah.
while meshing, it changes that original shape of that, means थोड़ा angle बड़ा छोटा हो सकता है, or it's like the proper element, in fact, like that only.
हाँ, it's a good question. So basically, क्या होता है कि whenever you are meshing a particular part, right? वो parts में the meshes may not like fit together properly. Like triangles and triangles sometimes may not like fit together properly. उसका, as you mentioned, उसका shape change हो सकता है. There might be holes in between the two meshes, or there might be cavities, or intersections between the meshes, which we call it as non-manifold. इसको एक non-manifold नाम का term होता है जिसमें two meshes या intersect with each other. So while meshing, उसका वो defects आते हैं कि those particular two triangular or tetrahedral meshes do not mesh together properly, and it may give defects in that meshing. But the software even has that kind of features to actually solve that particular issues. They have all that fill holes or fill cavities kind of thing, or you can like reduce the tolerance of your mesh, or you can there is a mesh control kind of an option, which in simulation softwares where you do this particular thing. So your question is absolutely valid कि उसमें shapes change होते हैं, उसमें problems आते हैं meshing में whenever, but you have to resolve them. with
Okay,
experience.
but manually we have to resolve it, or it does it
Yes,
automatically?
manually. Yes, there is an automatic option as well कि like automatic fill hole भी होता है अभी सॉफ्टवेयर जैसे जैसे नया नए बन रहे हैं लाइक एंसिस का नया वर्जन आ रहा है या सॉलिडवर्क्स अपडेट हो रहा है हमेशा तो उसके उसमें जो सिमुलेशन सॉफ्टवेयर है एफईए सॉफ्टवेयर है उसमें वैसे ही अपडेट्स आ रहे हैं कि ऑटोमेटिक यू कैन फिल द होल्स राइट नाउ आई विल शो यू दैट एज वेल कि वो फिल होल कैसे करेंगे या उसको कैसे मॉडिफाई कर सकते हैं मेश को मेश कंट्रोल कैसे कर सकते हैं जिसके योर मेशिंग विल बी यूनिफॉर्म एंड देयर वोंट बी लाइक यू नो element intersections और manifolds non manifolds as like that तो वो डेफिनेटली कर सकते हैं ऑटोमेटिक फीचर्स होते हैं उसमें
Okay, got it.
यस आई गो अहेड यस गाइस सो ये ग्रिड्स होते हैं गाइस तो अभी क्या होता है अभी मेशिंग आपने किया तो मेशिंग विल फॉर्म लाइक काइंड ऑफ अ particular structure or a surface which you can call as a grid so this is a kind of a structured grid which consists of this may be like a hexaedral meshing you know from the top if you look you can see that uniform layers which go about like combining with each other and forming on forming together however this is unstructured grid abhi if you can look carefully this particular part okay on which my cursor is moving this idhar ka jo element size hai wo kafi reduce karke rakha hai as compared to the others okay like I would like to ask you what might be the reason for this particular thing what do you think कि इधर इतना छोटा है साइज बाहर इतना बड़ा है ऐसे क्यों किया है उन लोगों ने लाइक सब जगह सेम क्यों नहीं रखा है what might be the case in this particular
Stress
thing
concentration.
sorry stress concentration but how will you know the stress concentration before you you know do the analysis this is meshing bro
Um,
meshing is done before the you are right matlab you can assume the stress concentration idhar zyada hai or idhar kam hai but how do you know before like doing that particular simulation
I think it is because so that we can get the actual shape which we have like
okay
inputted,
okay and
or
anybody
accurate shape.
I think it will be dependent on the different types of weight reduction which happens on the structure which is given. So,
okay. Weights which is acting on the structure okay
Weight
maybe
reduction. He said weight reduction.
weight reduction yeah
the holes and all that, it depends on that as well.
okay anybody else
Might be because there is some joint or something like that.
there's some problem or something like that okay
Hello.
okay
Can you-
yes all none of your answers are wrong like matlab you can have different interpretations for one particular problem but like I would just like to know more answers why do you think like idhar ka kam kiya hai aur bahar ka zyada and like why like what benefits will it give in meshing and in the further simulation what do you think
like in that region we need more accurate solution. That is the region of interest basically. Rest of the thing can be kind of
okay
neglected.
that's a good answer and why also like okay that might be the region of you know interest कि उधर ही तेरे को stress निकालना है okay but uh, okay what other things can you think of maybe okay this was a very good answer what you gave uh, what other things that can you think of कि इधर और क्या हो सकता है एक दो answers I'll like you tell me and then I'll go ahead with the explanation
So like what exactly is the mesh done for? Could you tell that?
this mesh bro it's a tetrahedral kind of meshing it's on a like surface this is on a particular part like so okay I will give you one more clue like this particular domain which is highlighted it consists of a little layers which are protruded and they are quite thin and intricate layer
Yeah, so
which
it's for the boundary lens maybe. If it's a CFD simulation. I think
okay
for the
good
boundary.
okay you are able to understand this well so basically इसमें क्या है कि suppose in any kind of a domain or a surface you have that kind of a feature or a part which is quite thin or like non-uniform as compared to the other rest of the domain, or like it is a little matlab, it is quite like a feature which is thinner as compared to does not have the same thickness, I will say, does not have the same wall thickness as compared to the other rest of the part. You will have to assign a separate size to that particular feature or that particular surface. The reason is because this particular mesh size on the rest of the layer or the part won't fit into this particular feature, because iska jo size hai और इसका जो स्ट्रक्चर है ये काफी छोटा है, इसका थिकनेस काफी छोटा है as compared to the other part. So if you like just put the same kind of mesh size for the entire domain, you will have inaccurate results in your simulation for sure. So you need to be very careful in assigning the right kind of mesh size in for those particular features. Sometimes it's little complicated ki there are a lot of features in which you'll have to assign different kinds of sizes, and like there are a lot of, especially a lot of features on your part. So in that there is an option of automatic sizing as well in your simulation softwares, where the software itself understands कि particular part को या particular feature को क्या size चाहिए या क्या size मिलना चाहिए. So it has that automatic features as well. Earlier it was not the same like that. Earlier you have to do it manually. You have to manually assign that size for like smaller intricate surfaces or domains. But this is the particular reason for it कि अगर आपका part एक particular part का wall thickness अलग है या shape अलग है या intricacies अलग है, तो you'll have to assign it a different size. Also, one student like who gave me that answer कि if this is particularly my area of interest, जिसमें मेरे को stress इधर का ज़्यादा निकालना है, I'm interested in calculating stress of this particular area. Definitely you need to assign a finer mesh for that particular domain or a part, so that you can get a better accurate result on that particular thing, and you can simulate it quite easily. Absolutely. Okay. So guys, अभी ये सब meshing के बारे में हुआ था. So I would like to move on to my injection molding thing. So basically I will tell you about what I did in my research paper and all in the further sections. But if you have any kind of doubt like before this before moving forward कि आपको कुछ भी पूछने का है तो आप just let me know. नहीं तो I'll move forward with injection molding and what I had done in my research paper and all those kind of things, and further simulation as well.
So like where exactly can we use the structured grid, like any application?
Structured grids, bro. One point I forgot to mention or tell you was key structured grids and bro, like in majority of the meshing analysis or meshes, you mostly use your unstructured grids only. क्योंकि उसमें क्या है कि you are able to get a kind of you are able to get the appropriate meshing for the appropriate features. Like you are not getting the same mesh size for the entire domain or that part. Okay, so that is why unstructured grids is used everywhere, like mostly everywhere. Structured grids may not be. It's used very quite rarely when the parts are quite simpler, or maybe it's a simpler hexagonal meshing. You will use structured grids when the complexities or intricacies are not that high. So in majority of the meshing applications simulations, you use unstructured grids only. So that is the thing. Yes. So
Hello, sir.
yes, bolo.
So can we combine hexahedral and tetrahedral elements together, or it's
Yes,
not possible?
that's a very good question. Actually एक hybrid kind of mesh भी होता है जिसमें I will show you in the simulation as well. तो hybrid mesh में क्या होता है, एक मिनट, hybrid mesh में क्या होता है, it is your tetrahedral meshing only, but it is separated by boundary layers, and it is a kind of a meshing in which you will get to see a few hexahedral elements as well, जिसमें hybrid mesh होता है. Like again, it is used according to the according to the simulation engineer's choice and the parts complexity and the domain. So hybrid mesh में you will get to see a combination of both in some extent, more of tetrahedral only, but generally but it will again have a lot of computational cost. मतलब वो कंप्यूटर को वो सिमुलेट करने में और रिजल्ट निकालने में काफी वक्त जाता है, and it is a trade off with lot of time, so that is possible. But generally बहुत ज्यादा यूज नहीं होता है, वो यूज होता है, ऐसे नहीं है. आई डोंट नो लॉट की, आई विल बी ऑनेस्ट कि आई डोंट नो लॉट की किधर हाइब्रिड मैश यूज होता है, पर होता है, फॉर श्योर होता है.
Okay, sir.
Yes. Also guys, और कुछ नहीं तो I will just give you a brief about my paper, what I had done, and I will move for the simulation, which will be an interesting part for you guys. Sir, do they want a like 2-3 minutes break or ऐसे कुछ? We can have a break for
No. Please continue because
okay.
they have a after break also they have a lecture. So please continue.
Okay. I will. Okay. Okay. So if you have any doubts, like let me know it later. So I'll quickly move on to my like paper kind of thing. I'll tell you in the paper what I had done, but this will I will now go up further into injection molding. The reason being, I have done my like FEA simulations on a particular software called SolidWorks Plastics, जिसपे finite element analysis से use किया है, मतलब तो. But before that, I would like to give you a brief about injection molding and RPT. I'm sure like you must have had RPT and these kind of concepts in your engineering, and so like can you like let me know about what do you know about injection molding in brief? Like I would like to take like 1 or 2 answers. Whoever is interested, please share your knowledge about what do you know about injection molding or RPT. What is it used for?
In injection molding, we insert a molten plastic. The plastic is first heated and then molted and injected into the mold using a high pressure piston kind of thing, and it conforms to the shape of the mold.
Okay. Anybody else?
It is used for mass production, basically.
Right. And why isn't RPT used for mass production up till date?
It's expensive, like the cost, machining cost and all. The
Okay.
3D printers and all, yeah. So to like cope up with the market,
It is
it's good
time
for
consuming.
analyzing and all.
Okay. Right. Good. So yes, as you both said, guys, injection molding is one of the most ancient and the most widely used techniques to manufacture plastic parts of all kinds of sizes up till date. Like even though 3D printing has been in use since a lot recently, matlab since like I don't know, maybe 10-15 in the last 10-15 years, like the new age 3D printing machines have been on like a real run to like produce produce parts in a large volume and to produce all these intricate parts. But injection molding still surpasses it because of its advantages to manufacture plastic parts more efficiently and with a great surface finish and accuracy. So in injection molding, like you can have trials quickly, like one trial for like 2 or 3 seconds can be done, like that not 2-3 seconds, sorry, like matlab like it will just take around like 5 to 10 seconds for one particular part to like be ejected out. And so it is definitely one of the most popular and widely used techniques up till date to manufacture all kinds of plastic parts. So it is yes. So now on the right you can see like this is a particular mold of a plastic spoon which consists of the cavity as well as the punch part. This is the female die this is the male die as well as the female die, which we call as the cavity as well as the punch. It is uh, like similar to any other molding operations. So yeah, all these kind of intricate plastic parts, toys, crayon box, plastic glass, writing pad can be produced through it, you know. So I'd like to show you a video of this particular injection molding process. This was when I had worked in an industry. This is how it actually forms, you know. Yes. So as you saw. So as you saw here, this is the strip. There is a male as well as a female die, the punch as well as the cavity. So the cavity moves inside the punch and the leg, and then it retracts back and then later the part is ejected out, and like it's a very quick process, you know. So this is a particular eye cup which is produced through it. Oh wait. Yes. Okay. Yeah. So as I mentioned, injection molding process is basically anybody is talking something.
Advait, I think there is a noise. Please mute yourself, everyone. आपके यहाँ से आवाज है क्या? I think आपके माइक में या तो कोई इश्यू है.
No sir, अभी ठीक है, अभी ठीक.
Okay.
Okay sir. So yeah. Sorry, I was like mistaken. Like the punch part moves inside the like what I said before. The punch part moves inside the cavity, and then it is a movable die. And this is a fixed particular die, and this moves inside it, and the part is then the packing takes place, and then the part is ejected out. So basically, injection molding process consists of injection. Injection में क्या होता है? यहाँ पर reciprocating screw से या जो screw होता है उससे plastic fill होता है, okay, cavity में through a runner. Then as the punch meets the cavity, the holding takes place or the packing takes place. फिर उसके बाद you know, in that particular holding or the packing, when the two dies meet each other, उसमें फिर थोड़ा cooling होता है with the help of cooling channels which are present in that particular die. So the cooling channels are actually straight drilled, okay? They are straight drilled through and through that particular mold. For example, like this is a particular mold, so इसमें so if you can see these particular, you know, holes over here, तो ये holes जो है ना वो actually वो cooling channels है जिसमें से अभी वो लगाया नहीं है वो ट्यूब वगैरह, तो the cooling, the water is, you know, circulated in and out through that particular mold or that plate. So cooling is one of the most important process in injection molding. जिसके वजह से it constitutes around 70% of the injection molding process, and one of the most major factors in determining the part shrinkage or warpage. Shrinkage or warpage क्या होता है कि अगर आपका part थोड़ा सा मतलब the deformation that you observe in your part, okay, due to non-uniform cooling or shrinkage, that is called as warpage. And then there is ejection. Ejection मतलब वो part आपका बाहर आता है. After your cooling process is done, after the part is sufficiently cooled, it is ejected back. So these are the types of injection mold: 2-plate as well as 3-plate. I won't go into details of it because you don't need to right now actually, because like it consists of this. If you want to like understand it more in detail, we may do it later. But right now it's like not necessary. But you can just understand what the injection molding process basically consists of. Yeah. So also this particular thing, factors affecting the part quality and the cycle time, also I will take through, like I will explain to you the further simulations, not right now, because you'll be able to better understand it in the simulations. Okay. So now let's move on to the simulations required for injection molding and how it is actually done. So guys, I'll give you a brief introduction of this software.
Advait, sorry to interrupt you. You have a lots of noise actually from your side.
Oh,
I think there's a problem with your speaker or something.
hello.
Yeah, we can hear you, but there is a noise. Previously, it was not there. It is coming. I think after that, after when you saw that video.
Hello. Now is it audible? Hello.
Now it is okay.
Now is it okay? Okay.
Yeah.
So yes, so it is a SolidWorks plastic software. It's a basically a pirated version of a SolidWorks, and SolidWorks Plastics is a module inside SolidWorks only. So this particular software is used to simulate the injection molding process. Okay. So as we do it in an industry, the same way.
Hello, Advait. Sorry, again it is coming. I think there's a issue with your speaker or something.
Okay.
You can take 1 minute. You just
Okay, sir. I'll just
mute yourself and just check your speaker setting.
just stop presenting for just 2 minutes, guys. Just bear with me for 2 minutes. I'll just come. Hello, sir. Am I audible?
Yeah, Advait, you're audible.
Okay, sir. Then we will continue with it now. Yes. Hello. Am I audible, sir? The voice is clear. Hello.
Yeah, voice is clear. Yes.
Okay, guys. So in between, like, if you have any voice issues, like, please let me know. I'll quickly fix it and like, okay. So yes. So as I was saying, the SolidWorks Plastic is a software used to simulate the injection molding process, and you are able to like in basically injection molding में क्या होता है कि you have these particular mold cavities. Okay, so this particular part is a pipe T joint, which is an automobile part actually made up of ABS plastic. तो अभी ये part का क्या है कि इसको this is a two cavity mold. ये दो parts है which are the part of that particular mold, and अभी इंजेक्शन मोल्डिंग में क्या होता है कि you have a runner system as well as a cooling channel system. Okay, so as you can see, I have made this particular runner system but with the help of sketches, and this is I'll further elaborate on the runner system how it is made actually. So इंजेक्शन मोल्डिंग में बेसिकली क्या होता है कि आपका जो प्लास्टिक है आपके रनर से फ्लो होता है कैविटीज में, मोल्ड कैविटीज में. Okay, so if I can show you in that particular thing mold, so if you can see this runner system, okay, this is the particular wait ये जो है अभी एक क्रॉस ऐसे क्रॉस बनाया है, दिस इज द पर्टिकुलर रनर. ओके, एंड इससे वो कैविटी में प्लास्टिक फ्लो हो रहा है. ओके, एंड फिर वो दिस पर्टिकुलर punch die will go into the female die, the cavity die, and it will eject the plastic part out. तो उसमें बेसिकली रनर होता है और कूलिंग चैनल सिस्टम होता है. तो अभी we can go forward with this particular simulation, and I'll explain you about the injection molding process as well as we go forward. So further, what we do in this particular thing is that we will do the meshing first in any kind of simulations, not just SolidWorks plastics, but in any kind of thing. Like ANSYS और SolidWorks CAM, SolidWorks CAM नहीं, सॉरी, SolidWorks सिमुलेशन या कुछ भी, आपको पहला मेशिंग करना होता है। पहला आपका पार्ट मेशिंग ही होता है। तो उसमें हम सॉलिड मेशिंग करेंगे पहले, बिकॉज दिस, एज आई टोल्ड बिफोर, कि whenever you want to run a cooling analysis in a particular like FEA software, तो आपको कूलिंग मेशिंग ही करना पड़ेगा, जिससे आपको एक एक्यूरेट रिजल्ट मिले। शेल मेशिंग भी कर सकते हैं इसके लिए, बट उसके लिए इतना एक्यूरेसी नहीं मिलता। एंड बेसिकली शेल मेश विल जस्ट, इट्स अ 2D mesh, as I told you before, and it will just mesh the outer surface, and not give the right kind of result to us. So solid meshing चालू करेंगे इसमें। So what we want to do is runner and cooling system design as well as a virtual mold generation. इसमें ऑप्शन होता है कि you want to do both of these things. Okay. फिर अभी आता है आपका cooling channel design. So I've already made a sketch of this particular cooling channel design. I'll just mark them. Oops, sorry. Yes. So this is the for the first cooling channel, and ऊपर एक दूसरा है. Yes. So अभी ये क्या होता है कि मोल्ड में कूलिंग चैनल्स होते हैं. Okay. If you don't understand what is a cooling channel, how it is, कैसे वो होता है मोल्ड में, किधर exactly place होता है, I'll just show you an image. इधर मैंने कूलिंग चैनल आपको दिखाता हूँ मैं. सो ये जो है, ये जो मोल्ड है ना, इसमें देखो, ये आपके ब्लू जो पाइप्स है, ये सब कूलिंग चैनल्स है, आपके कूलिंग पाइप्स है, जिसमें से आपका जो पानी है वो अंदर, इट गोज इन एंड आउट ऑफ दैट पर्टिकुलर मोल्ड, so that during the holding, okay, when the punch die goes into the female die, during the holding, your particular part can be effectively cooled. So and these cooling channels are straight drilled channels. Okay, you can see this particular pink figure, इसमें straight drilled होते हैं. Okay, तो वैसे कूलिंग चैनल्स वैसे होते हैं. सो इवन आई हैव मेड दीज पर्टिकुलर कूलिंग चैनल्स, आई हैव स्केच्ड दीज. ओके, एंड अभी इसमें अभी हम रनर भी डालेंगे. तो जनरली कूलिंग चैनल्स आर 10 mm इन डायमीटर. रनर डालेंगे हम इधर, विच रनर का साइज डायमीटर रखेंगे 6 and 4 mm. This one 6 and 6. और ये, और अभी ये जो रखेंगे, बिकॉज दिस थ्रू दिस पर्टिकुलर नोड योर प्लास्टिक इज गोइंग टू बी इंजेक्टेड, so that will we will keep it as 2 mm in diameter, the nose diameter. तो ये हम 2 mm रखेंगे हर जगह. टू या 1 भी रख सकते हैं, बट आई एम कीपिंग इट 2 हियर. ओके, तो ये हमारा रनर डिजाइन एज वेल एज द कूलिंग सिस्टम चैनल डिजाइन बन गया. अभी इसको हम वी विल जस्ट गो फॉरवर्ड. Okay, now this is basically a virtual mold generation. So the software actually easily calculates your mold design, mold generation, and you can like assign that size to it. थोड़ा आप इधर ये size you can adjust like in the X, Y, and Z direction. इतना चाहिए आपको ऐसे. But we will keep it default only, whatever the software has suggested us. So नहीं ऐसे आप you can like adjust it, like you can see it's coming lower. Then this the domain type. This is the all the procedures which go for it. मेन हाँ अभी ये meshing का part आता है, meshing का, ठीक है. I'll just hide the mold now. Now in this particular thing, this is a quite a complex figure. Okay. अभी इसमें you have to assign that particular size to your you know domain. Okay. अभी ये जो cavity है इसमें I have assigned it size 2.69. The software only has suggested us previously, as well as this particular thing. This is also around the same 2.65. But ये mold जो है, mold, ये जो outside mold है उसको 43 size रखा है. Reason being it's a large figure and you know तो उसके लिए meshing का size ज़्यादा ही रखना पड़ेगा. But इसका जो है 2.69 रखा है. Also there is a now as I told you before, assign size वाला option. Okay, assign size वाला. So what you can do over here कि आपको अगर चाहिए कि आपको कोई फिगर में या कोई भी या पर्टिकुलर सरफेस पे maybe this figure I want to assign a separate mesh size, so I can like change it over here, maybe 2 mm or maybe 1.5 mm. I want to make it finer, so you can assign it over here like that easily. So see this particular I've assigned 1.5, maybe this I want to assign something else, so you can do that for sure, like according to your needs and according to what you want. But this is just for understanding, so we will not right now, we will not assign sizes because अभी वो जो क्योंकि अभी क्या होता है कि after you assign the mesh sizes, ऐसे नहीं होगा कि आपको क्या directly meshing आपका accept हो जाएगा, नहीं. You will have to eliminate all the defects. You will have to see what is if the software says your surface mesh has failed, okay, then you will have to go back and again you correct your mesh and everything. So it's a continuous process. But right now I know कि इसको assign size करने की जरूरत नहीं है. इसको directly even if we keep these particular sizes, the simulation will run. So as I told, पहले आप surface mesh करते हो और फिर हम solid meshing करते हैं. तो इधर आपका ये देखो ये mesh हो गया इधर. फिर देखा आपने it's looking so good, attractive, as I mentioned the first point, for attractive pictures. Definitely it's looking so pleasing to the eye. And this is 2.65 mm. इधर ये mesh size assign किया और फिर ये mold है जिसको हम 42.11 का size जो सॉफ्टवेयर बता रहा है वो ही कर देंगे. You can reduce it as well, but right now I'm not doing it. Assign size नहीं किया ना, ठीक. हाँ, so अभी we'll go further. So now this is the most important thing. Now after I did my surface mesh, right, I have found out these particular defect that there are element intersections as well as non-manifold elements. Like these, when the boundary edges intersect with each other, or like the surfaces, the meshes intersect with each other, basically you get these particular problems in meshing. So there are a lot of element intersections, as you can see. There are 20 as well as 32 over here. The reason for this is that we haven't actually assigned any kind of size in this particular cavity. हमने एक ही size रखा 2.65 2.65 और उसके आगे हमने कुछ size वगैरह assign नहीं किया इसको, इसीलिए क्या है वो defects आएंगे ही. So you have to go ahead, you have to apply mesh control and you have to eliminate those mesh defects. और ये जो होता है ना कि हमको meshing का defects eliminate करना, ये सब simulation software में होता है, not just this particular software, SolidWorks Plastics. In ANSYS as well, in any kind of FEA software, you have to go eliminate the meshing defects because it's one of the most important part in your simulation कि आपका mesh uniform हो और सही तरीके से आए. तो अभी इसमें ये you can see so you can like this is all the mesh editing options that you have. So in this I'll go in the topology of the mesh. Okay. So as one of the guys mentioned earlier, ki can we like eliminate these defects automatically? So this is one of the
Advait,
yes,
sorry to interrupt. Hitendra here. Advait, where you have applied the surface mesh here?
yes sir, ये पहले surface mesh है.
नहीं किस पे वर्क पीस पे जॉब पे बिठाया आपने कि जो आपने आउटर डोमेन
नहीं
बनाया
सर
था उसपे?
नहीं सर, ये ना सिर्फ कैविटी, 2 कैविटी और फिर मोल्ड पे है।
ओके ओके ठीक है, प्लीज
हाँ
कंटिन्यू कंटिन्यू।
यस सर, श्योर सर। सो आगे जो रनर और जो कूलिंग चैनल होगा ना, उस पे जो मेशिंग होगा वो बाद में सॉलिड मेशिंग होगा आगे। लाइक एक्चुअली the reason for this, like I won't be able to, I can tell you my interpretation of this particular problem कि ऐसे वो क्यों करते हैं, कि मतलब मे बी सरफेस में जो कैविटीज पे ही उनको
No,
पहले से
that is okay. I just asked because I thought that on domain you are applying the surface mesh. That's why I asked. That's okay. You continue.
ओके सर, श्योर। सो भी मेश एनालिसिस में आपको क्या करना है कि आपको ये जो नॉन मैनिफोल्ड एलिमेंट्स है, इंटरसेक्शन एलिमेंट्स है, यू हैव द ऑप्शन फॉर डायरेक्टली डिलीटिंग देम। ओके, सो आप ये डायरेक्टली जाके उसको डिलीट कर सकते हो और ये एलिमेंट्स आपके निकल जाएंगे, लाइक यू नो। सो दीज पर्टिकुलर थिंग्स आर स्टिल ओवर हियर। अभी ये जो है ये ना, मैं आपको बताऊंगा ये क्या है एग्जैक्टली, रेड कलर मार्क थिंग्स। ओके, बट वी हैव एलिमिनेटेड द इंटरसेक्शन एलिमेंट्स एंड वो सब। नाउ देयर इज अ फिल होल का ऑप्शन। ओके, फिल होल्स। नाउ इफ यू कैन सी दिस पार्ट हैज नॉट बीन meshed properly because of its like अलग अलग mesh sizes है, and there are holes in between, like this particular figure। अगर आप देख सकते हो इधर ये रेड लाइन, दिस इंडिकेट्स these particular holes। ये लीडर लाइन का इधर एक ऑप्शन होता है which will show you कि किधर किधर क्या ये है, होल्स है। तो सी these part I will एक मिनट ये बंद करता हूँ that you can clearly see this। ये सब जो लाइंस है, लीडर लाइंस जो दिखा रहे हैं ना, वो दिखा रहे हैं कि आपके होल्स किधर है। So there is an option to eliminate these particular holes by just clicking on them. If I just click on them, see that the triangle gets completed, and that mesh in that particular part is uniform or correct. So I can just eliminate these parts, like this। तो मैं इधर जाके भी ऐसे कर सकता हूँ सेम। This is very important, like you definitely have to refer YouTube videos and like कि कैसे आप कर सकते हो, इसके लिए वो बेस्ट होता है, सब दिया होता है इसमें। But you have to keep on refining your mesh until you get the least number of intersection and non-manifold elements। अभी I'll show you one more thing। There is an option to automatically eliminate all the holes as well। there autofill holes का option भी है, जिसमें से आप पूरे सब ये जो holes है आपने eliminate कर सकते हो। So I clicked on that and all the holes are eliminated। As you can see, there is no particular hole problem in this now। So all the holes are basically eliminated now। This is the autofill option। So these all are the advancements in the softwares where you can eliminate defects automatically। बाकी काफी सारे हैं which we don't need it right now because हमारा problem mainly intersection elements और fill holes का ही था। So that is now eliminated। Now select a type of solid mesh। Default recommended is tetrahedral mesh, hybrid next step mesh। So इसमें अभी the software is only recommended कि ये particular part के लिए you need tetrahedral meshing because of its particular shape and domain। And like the softwares are actually designed in such a way that they suggest you कि आपको default mesh कौन सा use करना चाहिए, default parameters कौन सा use करना चाहिए, which has made the life of the simulation engineer and quite easy। And also for students like us, it has definitely helped us with that। But you definitely need to know कि किधर आप कौन सा mesh क्यों use कर रहे हो। कि अभी you can like give your whatever I had read about hexahedral mesh, I might be wrong as well, sir, you can correct me on this। कि according to me hexahedral mesh is used for parts which are not very intricate or complex, क्योंकि उसका computational cost ज्यादा आएगा according to me। But and it's according to the shape conformity as well। shape का structure कैसा है, design कैसा है।
That is correct।
okay sir, okay sure, thank you। So now we will mesh those particular cavity okay, cavity and runner as well with help of the solid mesh. अभी उसने हमको सजेस्ट किया था कि आपको हाइब्रिड मेश करना है. Actually, previously I had done it with using tetrahedral mesh as well. That will also work. But अभी हम उसने सजेस्ट किया तो हम यही यूज करते हैं. तो we will use earlier I had used tetrahedral mesh and given a mesh size of 1 but you can use whatever the software is suggesting you. So अभी ये देखो इसका जो minimum thickness of the boundary layer elements उसने suggest किया it should be 0.1. Then you can actually adjust the gradation, smooth चाहिए या sharp चाहिए या coarse चाहिए या fine चाहिए, just that. Okay, तो हमने we will just generally you should do what the software suggests you. Okay, so अभी हम इसको mesh करेंगे, create mesh. So इसमें थोड़ा सा like this is one of the most crucial things. If your surface meshing is done right, okay, without any kind of problems, then your solid mesh will also automatically be done accurately without any problems. So देखो अभी हमारा ये सब हो गया है. If you can see the mold नहीं दिखाएंगे, cooling channel अगर आप देख सकते हो तो देखो ये भी mesh हो गया अच्छे तरह से. You can see like the software as itself अभी ये जो है अभी इधर hexahedral mesh है. If you can see, okay, on the cooling channels is a kind of hexahedral mesh for these particular parts. इस पे tetrahedral है and on the runner as well it's a hexahedral kind of mesh. आप देख सकते हो कि सॉफ्टवेयर ने ही जो पार्ट लाइक जो नोड है रनर के थ्रू जो पार्ट में जा रहा है उसके उसके इर्द गिर्द कैसे उसने मेश को रिफाइन किया है. Okay, so you should really observe all those things and like try to understand it yourself only. Okay, you should really go into whenever you are doing any kind of simulation, go into total depth of it to like improve your understanding. So you can try and explain others as even if your understanding is wrong, even if it's not that correct, but still you try and do whatever you can. Okay, इसके आगे हम क्या करेंगे, मोल्ड को मेशिंग करेंगे. So mold को they have suggested us कि आप tetrahedral करो. I didn't change it, but they have told कि mold को tetrahedral करो. Maybe because of the mold size is big and tetrahedral meshing is better for it. Okay, because of its shape. So create mesh करना है इधर. Size उसने 1 mm दिया है. Till then guys हो जाएगा, इससे 2 मिनट में ही हो जाएगा, इसको इतना टाइम नहीं लगेगा because it will be done faster. If you have any kind of doubts or whatever you want to ask ना, please let me know. आपको meshing में अभी तक कुछ समझा नहीं है या कुछ भी explain करना है, we have time till 1:30. हो जाएगा, आराम से हो जाएगा.
Advait, there is one more thing when you say about the hexahedral mesh, or I'll say the when it is more than the tetrahedron. The thing is, whenever a volume, when we go for a finite volume analysis, that time that mesh is very important. Now look at your example. When we talk about the cooling channel have a fluid inside, right?
Right.
So that is the reason that it automatically takes the hydride mesh. Same with the runner. In runner also it is a plastic which is flowing through. So that's why it takes hexahedral. Suppose if I talk about the racing car, where I am more worried about the boundary layer separation of air. So in that case, what we do on the surface, outer surface, or you can say on the bonnet of the car, we try to create a smoothing layer, or I'll say a prismatic layer of this hexahedral mesh. Means
Okay.
along the car, inside the car, or where the mesh is applicable, we go for tetrahedron. But on the boundaries, we go for that because we need a smoothing, smooth transition, so we
Right.
could capture the more boundaries of the air.
Oh.
So that is the one thing. So whenever people differentiate between the, this is for students also. Uh, People differentiate between the finite element and the finite volume, but they are almost same. But whenever is volume is important for us, let's say example, I am doing the analysis of some fluid which is flowing through pipe. So in that case, I on the pipe I have to go for surface mesh, of course, because the friction plays very important role in that case. And inside the pipe, whenever consider the fluid, fluid का बाहर का जो layer रहेगा means that which touches to the inner layer of the pipe, that side it will be hexahedron. Yeah, Prachit.
सर जो हम लोग ने पार्ट लिया है फॉर मोल्ड, सर उसका जो मोल्ड का कैविटी होगा सर उसका बहुत कॉम्प्लिकेटेड होगा ना, बिकॉज वो टी शेप में है तो उसका जब
First of all, yeah, before you ask me question, I have to ask you question. Why you were absent for many lecture?
अरे सर एक्चुअली फर्स्ट इशू वो
Then I should
नेटवर्क का
not entertain. No, network is very common
ओके
issue.
ओके फाइन सर, नो
I should
प्रॉब्लम नो
not
प्रॉब्लम
entertain in that case. But
ओके
yeah,
फाइन
still you
नो
are
प्रॉब्लम
student, so I should entertain you. Tell
ओके
me,
नो
yeah, what is
प्रॉब्लम
your question?
सर एक्चुअली जो टी शेप का जो स्ट्रक्चर है, द पीवीसी टी शेप स्ट्रक्चर जो हम लोग मोल्ड बनाते हैं सर, अगर वो इंजेक्शन मोल्डिंग का प्रोसेस है तो सर उसमें जो अंदर का जो वेंट्स है उसको निकालने के लिए द मोल्ड दैट इज मेड, तो सर वो मोल्ड में थोड़ा सा डिफिकल्टी होगा ना सर फॉर
No, I didn't understood your question. What you are talking about? Tell me. You are talking about this particular part, or you are talking about
हाँ
something?
हाँ सर, तो जो पार्ट बना रहे हैं हम लोग, तो
हाँ.
उसका जो मोल्ड है, मोल्ड मतलब उसके अंदर टोटली थ्री 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 वेंट्स है राइट, तो टोटल स्ट्रक्चर है उसमें अंदर वी नीड थ्रू होल, तो
Hmm.
जब जब वो मोल्ड, ये इंजेक्शन डाई का पार्ट है राइट,
Hmm. Hmm.
तो जब भी वो मोल्ड बनाएंगे तो उसमें इट इज नॉट अ टू मोल्ड, वो मोल्ड ज्यादा होगा ना, फोर फोर स्ट्रक्चर में हो जाएगा ना आई गेस।
No, no. आपका जो मेल और फीमेल पोर्शन है ना, आई
हाँ
अंडरस्टूड, मतलब ये होल अंदर क्रिएट करने के लिए वो लोग कैसे करते हैं, दैट इज योर क्वेश्चन इनडायरेक्टली, राइट?
हाँ हाँ
हाँ, so it is basically what you are looking in different way and what we are looking as a different way. Okay,
ओके
this is how you are molding the, how you are setting up your die, that is also important.
अच्छा ओके
हाँ.
Bro, also what question you asked now, I have a
हाँ,
little bit of
diagram.
अच्छा ओके फाइन
explanation for that. अभी ये अगर आपने आई कप देखा ना ब्रो, आई कप,
या
तो
या
इसमें
आई
क्या
गॉट
अंदर भी एक कैविटी है, मतलब अंदर इट्स हॉलो. ओके,
यस यस
how have they done it? I'll just show you through this video थोड़ा सा.
ओके
अभी
ओके
थोड़ा
फाइन
सा
फाइन
सी.
या
इसमें
नो
क्या होता
प्रॉब्लम
है कि ये जो सॉलिड पंच पार्ट होता है ना, पंच पार्ट, उसमें ना एक स्ट्रिपर, देयर इज अ स्ट्रिपर प्लेट काइंड ऑफ अ थिंग, स्ट्रिपर प्लेट.
या
ओके,
आई नो स्टिपर प्लेट यस
या सो
ओके
उसमें क्या होता है कि उससे दे डिजाइन इट इन सच अ वे एंड देयर इज लाइक अंडर कटिंग गिवन टू इट एंड दैट शेप इज मेड इन सच अ वे that you are able to create that hollow cavity inside.
ओके
Okay, and you are able to eject that part out the way you want, मतलब वैसे. तो वो mold
ओके
designer का काम होता है. It's very quite extensive mold designing and वो process काफी ज़्यादा
ओके
extensive है. But
या
they design it like they are quite expert, the mold designers, in designing that particular part.
एक्चुअली अद्वैत, मेरा ये क्वेश्चन था कि जो सॉलिड वर्क्स पे हम लोग जो मोल्ड बनाते हैं राइट, तो
Okay.
अगर वो सी द मोल्ड कैविटी दे वुड डिजाइन एज पर द एल्गोरिथम्स दैट आर देयर, बट मेरे हिसाब से अगर ये मोल्ड टू पार्ट में बनेगा तो उसके अंदर यू हैव टू इंसर्ट समथिंग, बिकॉज वो मोल्ड हम लोग बनाएंगे बट रिमूव जो पार्ट रिमूव करने का जो टेक्निक है वो बहुत डिफिकल्ट होगा राइट, इफ इट इज मेड ऑफ मेल एंड
No,
फीमेल
it is
तो जो
not. It is not. See, that I'm saying, it is
ओके
basically totally how you are orienting the part.
ओके
There is a one orientation in which you can easily remove the part without disturbing the mold. I
ओके
understood your question. You are saying that this mold is not possible. Indirectly, you are saying that this mold is not possible in two piece. There should be a three piece because you need to create a hole. Okay. Is it right, Rachit?
हाँ सर एक्चुअली बहुत मतलब जो उसका कैविटी होगा ना उसमें बहुत ये होगा, मतलब ऐसा मुझे लग रहा है बिकॉज ईच होल नीड्स अ सेपरेट पार्ट, मतलब वो बाहर आ जाएगा, ऐसा मुझे लग रहा है। बिकॉज तीनों जो एक, अगर एक पार्ट हम लोग एग्जांपल लेंगे तो उसको एक होल जो है वो तीनों साइड में ओपन है, राइट, एक सामने से भी ओपन है और दोनों साइड से थ्रू होल है। तो अगर हम लोग उसको सिर्फ मेल और फीमेल में बनाएंगे तो जो अंदर का जो कैविटी है वो कहाँ जाएगा, एंड इफ वी मेक इट लाइक वो इनपुट का जो मोल्ड है वो एक ही साथ अटैचमेंट रहेगा तो पार्ट रिमूवल प्रॉब्लम हो जाएगा, ऐसा मुझे लग रहा
हाँ हाँ, अरे ब्रो, योर वो जो बोल रहे तो सही बोल रहा है। तो इसके इट
है।
इज नॉट जस्ट मेल एंड फीमेल, दिस
या
विल
या
हैव अ 3 कैविटी मोल्ड। अभी ये क्या है बताए, सॉलिडवर्क्स प्लास्टिक ये सॉफ्टवेयर है ना,
हाँ हाँ
ये पार्ट में यू कैन नॉट डिजाइन अ मोल्ड इन दिस पर्टिकुलर सॉफ्टवेयर। आई टेल यू द सॉफ्टवेयर, लाइक आई वाज गोना कम टुवर्ड्स इट एज वेल। लाइक जो सॉफ्टवेयर विच इंडस्ट्री पीपल यूज ना, वो होता
हाँ
है
हाँ
ऑटोडेस्क मोल्ड फ्लो होता है, ऑटोडेस्क
हाँ
मोल्ड
वही,
फ्लो।
हाँ 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 हाँ,
तो
ओके
उसमें क्या
जो
करते हैं, उसमें क्या करते हैं, लाइक दे विल हैव देयर 3 प्लेट मोल्ड। अभी ये 2 प्लेट मोल्ड में नहीं पॉसिबल है फॉर श्योर। इट विल नॉट जस्ट हैव अ लाइक रनर एंड लाइक कोर एंड कैविटी नहीं होगा इसमें।
अच्छा
इसमें
ओके।
और सब होगा इसमें तेरा, टॉप प्लेट, रनर प्लेट एज वेल एज द कैविटी प्लेट सब होगा, एंड स्ट्रिपर प्लेट वो सब होगा।
हाँ
So,
हाँ राइट।
but in this sort of software, you're not able to do it. This is just for like understanding purpose कि meshing आप कैसे कर सकते हो, और like थोड़ा मतलब approximate simulation purposes for education purpose, student level.
ओके
इंडस्ट्री में
ओके
ना, एक्चुअली इंडस्ट्री में जो Autodesk Moldflow सॉफ्टवेयर है, इट इज लाइक यू कैन नॉट डू इट पायरेटेड, मतलब आप नहीं इंस्टॉल कर सकते आपके खुद
हाँ
के
हाँ
पीसी
हाँ
पे, you
हाँ
have to buy it only. बट
राइट
उसपे
राइट
एक्चुअली दे एक्चुअली मेक दैट पर्टिकुलर मोल्ड practically, and like
ओके
the runner design, cooling tunnel design, and then they simulate it, and it gives the exact result as what you get on injection molding machine.
राइट
Autodesk
राइट।
Moldflow is the software. Yeah, yeah.
हाँ एक्चुअली मेरा डाउट वही था, बिकॉज इवन आई
हाँ
वाज ट्राइंग 4 पीस डाई ऑन सॉलिड वर्क्स, बट वो जो स्टिमुलेशन था वो मिल ही नहीं रहा था। सो आई वाज लाइक
हाँ
इफ मतलब जो पार्ट आपने लिया ना वो इट इज ऑफ दैट काइंड, सो आई थॉट कि देयर आर सम ऑप्शंस बिकॉज आई कुड नॉट फाइंड इट ऑन ऑनलाइन। सो उसके लिए अभी मुझे सेटिस्फेक्शन मिला कि यू हैव अनदर सॉफ्टवेयर, सो
yeah
आई
yeah
गॉट
yeah
इट।
I'll definitely
ओके
tell you the name of the software, like
ओके ओके
especially Autodesk Moldflow और Moldex 3D नाम का सॉफ्टवेयर है, Moldex 3D। तो वो
ओके ओके
मैं आपको बताऊंगा आगे भी फटाफट वो क्या होता है सॉफ्टवेयर, और उधर ही यूज करते हैं वो मोस्टली।
ओके, नो प्रॉब्लम नो
ओके, बट दिस इज लाइक फॉर मेशिंग, तो आप अंडरस्टैंडिंग टू व्हाट इज मेशिंग एंड वो सब। ओके,
प्रॉब्लम।
तो लाइक अभी हमारा वो सॉलिड मेश हो गया है। तो इसमें अभी क्या हमको दिख रहा है कि दिस इज अ कंप्लीट टेट्राहेड्रल काइंड ऑफ अ मेशिंग, ओके, विद ऑल द सेपरेटेड बाउंड्री लेयर्स, एंड यू कैन सी कि रिफाइनमेंट कैसे हुआ है। लाइक द सॉफ्टवेयर हैज it's itself refined that particular mesh at the nodes and the elements that it requires to. So this is like, and it actually looks so pleasing to the and creative, you know. So this is one of the advantages of FEA. This is not a very, I honestly tell you guys, like as Rachit, what's your name? Rachit, right?
Prachit.
Rachit, yes. So as he mentioned कि ये जो मोल्ड ऐसे प्रैक्टिकली ऐसे तो नहीं ऐसे नहीं होता है, ये सब वर्चुअल मोल्ड, दैट्स व्हाट इज गिवन द टर्म वर्चुअल, कि ऐसे एक अप्रोक्सीमेट मोल्ड है कि जिससे हम सिमुलेट कर सकते हैं। इट विल नॉट गिव द एक्चुअल रिजल्ट्स, बट those softwares like in Autodesk Moldflow and Moldex 3D, you can actually get the really accurate results as like, and they use it actually to find the warpage, shrinkage. Okay, तो अब ये हमारा हो गया है। तो we'll
One more thing, Advait, here software applies the axis symmetry, right?
axis symmetry. What,
Yeah,
sir?
you have given axis symmetry, or software is automatically taking axis symmetry?
सर सॉफ्टवेयर ही लेता है वो। हाँ मतलब
axis
मोल्ड
symmetry.
कौन सा डायरेक्शन में होना चाहिए वो सब ना सर, मतलब
No. There are two components you have shown, no, but एक ही component के लिए उसने किया है, because he knows that other side is the same thing is there.
नहीं सर, क्लिपिंग प्लेन है सर, एक क्लिपिंग प्लेन है, लाइक वो ना इधर नीचे क्लिपिंग प्लेन है ना, ये उसने खुद से ही किया है एक्चुअली ये।
हाँ, that I'm saying कि
हाँ खुद से ही
half
किया
of the meshing, and he will run the analysis for half of the component, because you know कि other thing is same, right?
है। yes sir.
See, here he is showing the mesh for only half of the side, so the overall simulation will also run for half of the size, because the other half is the mirror of this. I'm correct?
सर एक्चुअली ना ऐसे नहीं है एक्चुअली, क्योंकि क्या बताया गया नीचे जो क्लिपिंग सेटिंग्स है ना, इफ आई जस्ट एक्सटेंड इट कंप्लीटली वो तो मतलब ये देखो, मतलब ये जो है ना done for the entire domain है, दिखा रहा था वो क्लिपिंग थी, done for the entire
Advait, you are not audible.
Hello, sir.
Now it is okay.
Now it is okay, right? Hello, am I audible now, sir?
बहुत कम आ रहा है, but it is audible.
Hello, I will speak a bit louder. Hello. Okay.
Yeah, okay.
तो अभी ये हमने सब कर दिया, like you know, अभी machine solid machine में कर दिया. तो अभी लास्ट प्रोसीजर आपका मेनली यही होता है कि आपको क्या उसमें डालने है.
Yeah, I understood वो because just to show the mesh you have shown, but हम लोग ने अगर half of the component लेके भी meshing करके भी किया होता तो results will be same, no? Because along the runner, your voice is like coming very very low actually, Advait.
Hello.
Can you check your troubleshooting issues or something is there? I think you can off your screen. Yeah, you can off share. Advait, you just check till that I'll explain to the student. See, in practical we have a axis symmetry element, right? So there are two things: axis symmetry problem and axis symmetry element. So axis symmetry, this can be considered as the axis symmetry problem also, right? Whenever related to the axis, there is the same thing is there. Okay, you can take half of the object and you can do the simulation because for another half the result will be the same.
Sir.
हाँ, Digant बोलिए.
Sir, but the cooling channels are not symmetry, huh, sir?
How it is not symmetry?
Sir, means it is like the continuous, sir. मतलब दो parallel एक
Okay,
joint है, sir.
yeah, I agree. In that case, if we are considering the cooling channel, then it is not symmetry. I agree.
Yes, sir.
Then we cannot do, correct. Where is Prachit? है?
सर अभी आवाज आ रहा है.
Yes, sir. Hi.
म्हणजे आम्हाला दुसरं रजिस्टर बघ
Yes, ठीक है. So Prachit, your question was not related to FEA. Your question was related to some mold design.
हाँ सर, तो अद्वैत सर ने एक्सप्लेनेशन बराबर किया तो इसलिए मैं पूछ रहा था कि वो मिल सकता है बिकॉज आई वाज फाइंडिंग सॉफ्टवेयर वो मिल नहीं रहा था.
Okay. ठीक है. I thought दोनों mix कर दिया. So you try to find out softwares, you try to find out everything, but you don't sit for lecture, right?
Sir, actually,
No, I understood. Teachers are just, making you bored, so that is okay. Yeah, we'll discuss later on. Thank you. Advait, you can continue. Yeah.
सर आवाज आ रहा है क्या मेरा?
नहीं Advait, I think some issues there. आ रहा है लेकिन बहुत noise है.
Hello.
अगर आपके पास हेडफोन है Advait तो प्लीज हेडफोन चेंज करके देखिए ना.
ओके. हेलो सर,
प्रॉब्लम
अभी आ रहा है?
Yeah, now it is quite okay.
Hello.
Yes. Please continue. Yes.
Okay, sir. Yes. कुछ तो चल रहा है. Yes. तो अभी हमारा इधर मेशिंग हो गया, ठीक है. Now the only step which is remaining is you have to put the injection location in this. Okay. Add location करो इधर we will put it here. Now the design of your runner as well as the injection location is very important. अभी इधर हमने कैसे दिया है, this is called as a pinpoint runner system. It's a circular runner but it's a pinpoint. ये जो point है, it is like protruding towards the end, and so it's called a pinpoint runner system. Okay, branch runner system है ये. Injection location भी मैंने exactly symmetric दिया है बीच में.
that there is equal flow into both the cavities at the same time, वो बहुत जरूरी है. नहीं तो एक पार्ट पे आपको अलग values दिखेंगे, दूसरे पार्ट पे दूसरे दिखेंगे. So that is very important. So I've added the injection location over here, okay, and I selected add location. बाकी सब like you have to just put the process पर like fill settings करना होता है आपको. Fill settings में अभी जब आपका प्लास्टिक जाएगा पार्ट में तो आपका क्या what filling time you want to keep it or melt temperature. Now melt temperature is according to the material that you choose. So here we have chosen the material as acrylonitrile butadiene styrene ABS. Okay, ABS is a plastic which is quite it's a semi-crystalline material. इतना ज़्यादा उसको quite tough और resistant होता है वो. इसका impaction बहुत अच्छा होता है. And it does not warp a lot. It gives a very smooth surface to like feel. I'll not say surface finish, but a smoother surface is like obtained, like a kind of a surface. If you like if you feel that particular surface, you will feel that it's very smooth and like glossy kind of thing for the hand. So अभी इधर जो है filling time, melt temperature, mold temperature, injection pressure, clamp force, it's all according to the software. Mold temperature होता है according to the ABS. So according to the what the software is suggesting us 50 degree centigrade रखना चाहिए. Injection pressure क्या होता है कि when you fill your cavity with that particular plastic, तो आपका with what pressure is it injected into the mold cavity or into the part? That is your injection pressure. Okay. Now these particular terms, injection pressure, mold temperature, melt temperature, ये जो है ना, ये सब जगह आपको यूज करने को मिलेंगे. मतलब Autodesk mold flow में भी आपको दिखेगा ये सब पार्ट चीजें. If you want like those guys who are interested, then write down the name of that particular software which is currently in use in the industry on a large scale. It's called Autodesk mold flow. I will even tell sir that I'll WhatsApp करूँगा sir को नाम, तो sir can forward it to you as well. अभी आगे fill settings होने के बाद there are पैकिंग सेटिंग्स. ये भी सब डिफॉल्ट ही होते हैं. पैकिंग मतलब पंच और डाई मेट करने के बाद कितना टाइम वो होल्ड करता है एक दूसरे को जब तक प्लास्टिक उसमें ठीक से भर जाए और फिर उसके बाद कूलिंग चालू होता है. सो बिफोर कूलिंग दिस पैकिंग प्रोसेस टेक्स प्लेस. ओके, इसका प्रेशर होल्डिंग टाइम एंड प्योर कूलिंग टाइम, ऑल दोज सेटिंग्स आर ऑलरेडी डिफॉल्ट. देन देयर इज कूलिंग सेटिंग्स. ओके, इसमें भी वही है कि फ्लो रेट क्या होना चाहिए आपका 150. नाउ द कूलेंट टेकन हियर इज वाटर. सो अकॉर्डिंग टू द so generally for water that flow rate is particularly default, which is 150 cc's per second. Mold opening and closing time 5 second रखा है. Air ambient temperature 30 degree centigrade, and this is the even melt temperature of the ABS plastic. Ejection temperature मतलब आपका पार्ट बाहर आने के बाद, कैविटी से बाहर आने के बाद क्या आपका होगा, what temperature will it exit that particular mold cavity is the ejection temperature. अभी one important thing to notice here is the melt temperature to 230. मतलब when it goes into that particular cavity तब 230 degree centigrade है. Okay, फिर वो कूलिंग उसका पैकिंग होने के बाद, कूलिंग होने के बाद then it is reduced to 90 degree centigrade. There is substantial amount of cooling which is observed as the part enters the mold and it cools down. So this role of this cooling channels is extremely important when you look at injection molding. Okay, so अभी इसके बाद है नहीं, ये नहीं, sorry, अभी इसके बाद है warp settings. Warp settings are also default. Ambient temperature is outside surface outside temperature 30 degree centigrade रखा है. And the gravity. Now अभी warpage क्या होता है guys? Warpage मतलब क्या, as I told you कि अगर non uniform cooling हुआ, अगर cooling ठीक से नहीं हुआ तो the part might deform और थोड़ा सा ऐसा bend हो सकता है and इसका defect हो सकता है. Like if you, I'll show you what is warpage ahead as well. तो अगर वो ऐसे हो गया तो उसमें the part might not come out as it is expected or as it is as the manufacturer wants. So you need to have minimum warpage, and warpage is a very important big defect in injection molding, which all the designers, mold designers and engineers want to control. अभी इंजेक्शन लोकेशन हुआ and then you directly run the analysis. Now obviously I'm not going to run the analysis because I have already run that particular analysis. Okay, so I'll just show you that analysis, the run वाला analysis. अभी ये जो एनालिसिस मैंने रन किया वो थोड़ा पूरा रन नहीं हुआ, थोड़ा सा उसमें ना टाइम लग रहा था रन होने में, but I've run the 3/4 analysis, so I will just show you fill, pack and warp results in that. But luckily I've captured the images of the results as well. कि results क्या आते हैं इसमें. So basically you have in this particular injection molding FEA software, you have 4 kind of results, which is cooling, packing, warpage, as well as cooling, as well as fill.
Advait, if you have result, you can directly show the result because I know the simulation will take times, no?
नहीं सिमुलेशन नहीं कर रहा हूँ सर, मैं वही रिजल्ट ही खोल रहा हूँ, खोलने में ही 2 मिनट लग रहा है.
अच्छा,
हाँ सर, मैं फटाफट दिखाता हूँ रिजल्ट अभी.
ओके.
अच्छा, till that result comes, I'll just show you the. Okay, wait, it's coming. हो गया, thank God. हाँ, चलो अभी ये results मैं आपको दिखाता हूँ. तो ये देखो. So I'll first show you the flow results. Guys, this simulation hasn't run like totally completely, so we'll have to just settle on the flow, pack and warp. Cooling results नहीं है इसमें, as I told you. But मैं आपको cooling results के पहले एक simulation run किया था, उसका मैं आपको दिखा सकता हूँ. मैंने एक फटाफट किया थोड़ा सा ये सिमुलेशन. So if you can see this particular, this is very attractive actually. Solid plastics give you, उसका graphics काफी बहुत अच्छा है. So you can see the simulation. So it's like filling the part, you know. अभी इधर if you can observe थोड़ा unequal filling है. I'll be honest, थोड़ा unequal filling है. इधर थोड़ा सा पहले fill हो रहा है इधर. Maybe it's because of the injection location. थोड़ा घाई में थोड़ा सा even if by millimeters, even if like microns, even if you like misplace the injection location, it will give improper filling. But this is for demonstration purposes कि आपको results क्या मिलते हैं. Okay, so now it will give you all these results like pressure at the end of filling, part fill होने हाँ part fill होने के बाद pressure क्या आएगा आपका. So this is not accurate. Don't go on the results values, but you can just understand कि कौन से results मिलते हैं. And you can like later simulate it yourself because the software is like easily free. It's not pirated आप कर सकते हो. Pressure at the end of fill, temperature at the end of fill, ये सब cooling time at the end. This is for filling. You have a pack results. Packing results में जब वो मेल एंड फीमेल एक साथ मिलते हैं तब आपको क्या रिजल्ट्स मिलते हैं. It's the same pressure at the end of packing. Then you have this result advisor which gives you the thorough, explanation for each result as well. And it's a very this particular software may not be used by industries, but for your own for your own personal understanding, for educational purposes, it's excellent to understand some of the basic things in injection molding. घर बैठे अभी कभी इंडस्ट्री बंद है तो आप ये सब घर पे कर सकते हो. नहीं तो यू कैन नॉट गो देयर डेली ना, कभी कोरोना की वजह से कभी बंद हुआ तो अभी दिस warpage result is also not accurate, but I'll tell you what is basically warpage. अभी 1.7862 दिखा रहा है. तो warpage क्या है, it can show you that particular animation as well. This total deformation. अभी I'll just set that scale to around 10. तो ये warpage क्या होता है कि it will show you कि आपका part कितना डिफ्लेक्ट हो रहा है या डिफॉर्म कितना हो रहा है because of these particular because of non-uniform cooling or shrinkage. So that you can see by using the warpage. ये थोड़ा सा गलत दिखा रहा है, but it's fine. Like you can understand कि कितना defect हो रहा है in the x, y as well as z direction. You have that. Okay. Right. So you can understand all these results. You have a summary of the results and all. So like we have just half an hour remaining, guys. और आपको इसमें सॉफ्टवेयर में कुछ अगर पूछना हो तो मेरे को पूछ लो, नहीं तो I will just move on to the paper thing what I have done. I'll quickly explain the paper thing in the next 20-25 minutes. आपको अगर इसमें कुछ पूछना है तो पूछो. Hello.
No, I think they don't want to ask anything, Advait.
Okay. So अभी मैं क्या करूँगा?
सर
Yeah, Digant, I have one question. Wait, Advait.
सर मटेरियल अनसर्टेनिटी भी कंसीडर किया जा सकता है?
Yes, absolutely. Material uncertainty. Like, can you elaborate a little bit about on your question?
Like means विस्कोस थोड़ा कम ज्यादा हो गया कोई सेक्शन में, या मटेरियल में कुछ डिफेक्ट आ गया मैं फ्लो करने के समय, something was like
material में defect. Actually bro, material में like the material is chosen according to the part. Okay. अभी इसमें कैसा है? Now the material chosen here was ABS. अभी ABS कैसा है mentioned is a quite a impact strength उसका काफी ज्यादा है और it's tough. So उसमें क्या होगा कि उसमें warpage कम आएगा because उसको deformation क्या होता है basically it's on the basis of molecular structure. अगर आपने पहले उसको इंजेक्ट किया, फिर मतलब ड्यूरिंग इंजेक्शन इट इज एट अ वेरी हाई टेम्परेचर, फिर उसके बाद आपने उसको पैकिंग करने के बाद कूलिंग किया, जब हीट व्हेन यू हीट दैट व्हेन द पर्टिकुलर प्लास्टिक इज हीटेड, ओके, तब ऑब्वियसली इट्स मॉलिक्यूल्स विल सेपरेट, यू नो, इट विल वो they will you know deform the molecular, it will like the molecular structure will only deform, okay, but like when you will cool it, the molecules and the atoms will come together, right? So ABS में क्या होता है? ABS में whenever you heat that particular you know plastic, and then the molecules deform, but when you cool it down, it comes back to its original position. So उसके वजह से क्या होगा कि डिफॉर्मेशन ज्यादा नहीं आएगा पार्ट में, एंड दैट इज ABS से जो भी पार्ट्स बने होते हैं उससे ज्यादा वॉर्पेज नहीं आता. बट इन कंपैरिजन टू दैट विद पॉलीप्रोपाइलीन PP, व्हिच इज अ वेरी इंपॉर्टेंट प्लास्टिक, पॉलीप्रोपाइलीन में ज्यादा वॉर्पेज आता है, ज्यादा डिफॉर्मेशन होता है, क्योंकि आफ्टर ऑन हीटिंग your atoms or molecules deform, they separate out, but when you cool them down, okay, they don't come together, they don't join and come back together. अगर आपने जो केमिस्ट्री में देखा होगा, atoms when you heat them they separate out, they expand, and then when you cool them they come together. But PP में क्या होता है? PP में वो पॉलीप्रोपाइलीन में वो सेम ही रहता है, मतलब वो molecules they remain deformed and extended throughout branch and they don't come together, so warpage उसमें ज्यादा बढ़ता है PP में, पॉलीप्रोपाइलीन में. So you know, according to the part structure, according to the you know according to the part and according to the warpage and the defects that you want to eliminate, you have to choose the plastic wisely. Now suppose bottles किससे बना होता है? Can you tell me what are bottles made of? Plastic bottles. So plastic bottles are made of PET, right? Polyurethane. कुछ तो I don't know exact PET, you know, I don't know the exact full form of it, polyethyl tetrafluoro ऐसे कुछ तो है उसका. But PET, now PET is according to the plastic properties that they want, that they don't want it too hard, you know, they want it a little bit more elastic properties, वो सब चाहिए, viscosity at थोड़ा सा चाहिए उसमें, so they choose that particular plastic according to that. एंड द मोल्ड डिजाइनर्स को काफी उनको एक्सपीरियंस होता है कौन सा प्लास्टिक कौन से पार्ट के लिए जरूरी है. सो अभी आगे पढ़ते हैं गाइस कि अभी इसमें क्या है. आई विल जस्ट गो ऑन विद माय रिसर्च पेपर एंड फर्दर थिंग्स, ओके. हाँ, तो अभी इसमें एज आई टोल्ड यू, लाइक these are all the factors which influence the part quality and the cycle time. I'll come back to all this during the explanation of the paper itself. So I told you अभी जो है polypropylene और ABS are the most important to plastics in injection molding, or the kind of plastic what you want to use depends on the part and the warpage or the defects that you want to control. तो इससे काफी influence होता है. अभी cooling and gating systems, I'll quickly explain you a bit about the. Sir, they want to leave it perfectly at 1:30 or like 5-10 minutes extra is okay.
That totally depends on them.
Okay, जिनको रहना है आप रह सकते हो. मैं थोड़ा आपको अगर कुछ होगा तो. But
Yeah,
this
yeah.
might go like extend just for 5-10 minutes only, not more than that. I'll try to cover it in 20 minutes only, 20-25 minutes. So I'll.
Yeah, go ahead.
Yeah. तो अभी इसमें कैसे होता है इंजेक्शन मोल्डिंग में, जिधर मैंने इंटर्नशिप किया था ये उधर के फोटोज है कि इसमें कैसे होता है. देयर आर लॉट ऑफ नंबर ऑफ कूलिंग चैनल्स एज अ रनर सिस्टम व्हिच आर डिजाइंड. ये बैफल कूलिंग होता है. बैफल कूलिंग में क्या होता है कि ये स्ट्रेट रेल्ड ओनली, जस्ट उसमें बीच में स्लिट दिया होता है जिसकी वजह से आपका जो पानी है एक पार्ट से अंदर जाएगा और बाहर उधर दूसरे पार्ट से बाहर आएगा. So it will like try and cool that part more effectively throughout. These are like the channels which are drawn into that particular baffles. This is called as a baffle cooling, which helps to like cool the part effectively throughout and uniformly. Then if you can guess, like can someone tell me इधर ये जो अभी है बेरिलियम कॉपर कोटेड मोल्ड जो अभी इधर रखा है, ये अभी बाकी जो मोल्ड्स थे वो बाकी P20 hard steel के ही थे, like the molds are made of P20 hard steel. Why do you think have they coated this particular mold? Can you think of something? One or two answers.
Curing facility, maybe
Yes,
insulating.
absolutely. It's because of the insulating properties of beryllium copper. That क्या बोलते हैं उसको? Alloy, beryllium copper alloy. Because of that, it provides that particular alloy provides you excellent insulation and thermal cooling properties, which helps to cool the mold effectively. अभी जो part है वो काफी बड़ा है और उसका wall thickness भी है ना काफी ज्यादा होता है ना. It's a very basic observation कि अगर आपका part का wall thickness ज्यादा होगा तो आपको cooling भी उतना ही लगेगा, right? अगर part का wall thickness कम रहेगा 1.5 या 2 mm ही रहेगा तो उसको कूलिंग कम लगेगा. सो अकॉर्डिंगली द मोल्ड्स आर डिजाइन, दे आर मोल्ड इन सच अ वे, बहुत जुगाड़ वगैरह सब कुछ करते हैं अपने इसमें. उसको कोट किया बेरिलियम कॉपर से, रनर कूलिंग चैनल्स ज्यादा नहीं प्रोवाइड किया इन ऑर्डर टू सेव कॉस्ट मे बी एंड दैट काइंड ऑफ थिंग्स. सो दे हैव ऑल दीस काइंड ऑफ थिंग्स व्हिच आर व्हिच दे यूज. सो अभी दिस इज सबमरीन गेटिंग सिस्टम. इसमें क्या होता है कि आपका जो ये जो सब कैविटीज है, मल्टी कैविटी मोल्ड है, ये कितने सारे है देखो 1 2 3 4 5 6 कैविटीज एंड 2 ब्रांचेस इन दिस, जिधर से जाएगा 1 and 2. सो अभी इसमें कैसा है कि इट इज प्रोवाइडेड विद अ सबमरीन गेट. इधर एक देयर इज अ स्मॉल गेट और अ होल व्हिच इज मेड एंड द प्लास्टिक इज इंजेक्टेड इनटू दैट गेट थ्रू दैट पर्टिकुलर होल. There are different kinds of gating systems which are done. This is a multi cavity one. अभी आपको किसी को कॉन्फॉर्मल कूलिंग की आइडिया है? किसी को कॉन्फॉर्मल कूलिंग क्या होता है एंड हाउ इज इट यूज्ड एंड व्हाई इट इज यूज्ड? Anybody knows about conformal cooling? What it is now, I showed you all the straight drill cooling. This is called as straight drill or traditional cooling, conventional cooling. Conformal cooling क्या होता है? आपको क्या लगता है क्या हो सकता है? Anybody? Right. Yes. This is a good answer. This is a good answer. So basically अभी conformal cooling क्या हो सकता है? Conformal cooling क्या है कि कि basically अगर आप cooling channels, if you want to effectively cool the part throughout all the entire portions and through all the surfaces, curved edges and intricacies, you need to have those particular cooling channels which pass through each and every domain and surface. So for that you need a cooling channel which is not just straight drilled, okay, and linear. It needs to conform to that part. That is called conformal. It conforms to that entire part. So these particular conformal cooling channels, as you can see, ये एक prototype है जिसमें क्या है कि एक cavity है, mold cavity है जिसमें से conformal cooling channels दिखाए हैं कि ऐसे वो they are conforming toward the shape of the part. So these are particular parts are made by direct metal laser sintering, okay. इसके वजह से क्या होता है? This is an excellent method in order to cool the parts. इससे आपके defects like warpage, shrinkage काफी ज्यादा कम आते हैं and you can really, save a lot of cost and computation time. Obviously, DMLS is a costlier method, so you cannot invest a lot. Like गाला कंपनी होते हैं इंजेक्शन मोल्डिंग, वो अभी DMLS वगैरह यूज नहीं करते हैं, DMFD फ्यूज डिपोजिशन या DMLS नहीं यूज करते, क्योंकि उनका बेसिकली वही होता है कि इंजेक्शन मोल्डिंग करो, कूलिंग करने के लिए ऐसे कोटिंग वगैरह करो मोल्ड को, या कूलिंग चैनल्स ठीक से बनाओ एंड अपने एक्सपीरियंस पे खेलो. बट दे विल नॉट यूज ऑल दिस DMLS. दिस इज डन इन द फॉरेन, mostly the foreign companies, ज़्यादातर. But this particular method really helps you to cool the mold very very effectively.
Bro,
अभी
हेलो
अरे
ब्रो वो मोल्ड के अलॉन्ग कूलिंग टेक्निक्स लगा ना, वो डायरेक्ट बहुत मतलब इट्स वेरी कॉस्टली, मतलब टू मेक होल्स अलॉन्ग विद द मोल्ड तो बहुत कॉस्टली हो रहा है, और उसके लिए जो मशीन रहती है वो बहुत कॉस्टली होता है.
एब्सोल्युटली बहुत कॉस्टली होता है
वो मैन्युफैक्चरिंग के लिए बहुत. उसके अलावा अपना ट्रेडिशनल मेथड लेके उसमें कूलिंग चैनल ज़्यादा रख के सेम थोड़ा इफेक्ट आता है. बट दिस प्रोसेस इज़ वेरी गुड. बट जो अगर मोल्ड का डायमेंशनली वो अगर कॉम्प्लेक्स है तो इतना कूलिंग कॉम्प्लेक्स के लिए जो टनल्स है वो मोल्ड में उतारना, मतलब टू ड्रिल दोस होल्स इज वेरी डिफिकल्ट. कर्व होल ड्रिल करना बहुत डिफिकल्ट.
No bro, this is not done by drilling. Now this is done by DMLS. मतलब this is additive manufacturing. So laser sintering से एक एक करके वो जो particular die है, like if you can see this, like I'll show you further examples of DMLS, like वो कैसे बनता है. But this is basically done by laser sintering. वो कैसे करेंगे उसको, कि उसको लेजर से they will keep on making those particular that particular entire mold cavity, and they will not drill it. वो ड्रिलिंग वगैरह नहीं करेंगे ब्रो उसमें.
ड्रिलिंग इम्पॉसिबल है, ड्रिलिंग इम्पॉसिबल है. वो मतलब मेटल डिपोजिशन मशीन आता है लेजर वाला, उससे काम होगा.
हाँ उससे ही होगा, उससे DMLS से ही होता है. दिस इज नॉट डन बाय ड्रिलिंग एंड ऑल. दिस as you mentioned, इसका computational cost quite high है, but at the same time like अभी ये लोग है ना, like गाला कंपनीज में नहीं यूज करते because they are dependent on their age old techniques. Okay, but in the foreign companies it's really on a great use right now. Okay, because उनका क्या है कि even if the manufacturing cost is high, after they finish off the manufacturing of that part, and after they get the आउटपुट कि उसका इतना कम वॉर्पेज मिला, इतना कम श्रिंकेज हुआ है, कूलिंग टाइम इतना कम रिड्यूस हुआ है, फटाफट पार्ट 2-3 सेकंड में कूलिंग टाइम if it was taking maybe 15 seconds, it has come down to 8 or 9 seconds. So that is a excellent trade off per trial. Instead of 1,000 parts, maybe I can produce 3,000 parts in the same time. So if that is the trade off, then definitely that particular cost is क्या बोलते हैं,
compensated.
हाँ मतलब it is compensated. That particular cost is again compensated for the high machine cost. And एक बार करके ना, अभी कैसे है पहले, like it is actually like I have even thought about this. Like पहले कैसे earlier just you were manufacturing on lathe machines, and ज़्यादा so that it would be a lot of labor intensive work, and it would be. But पहले लोगों को क्या लगता था कि यार lathe machines पे ही कर सकते. Now there are CNC machines. Now there are so many automats and robot automation which is used in industries. So people didn't know about it later, but after they understood the advantages of this particular thing, then they started using it, and unko fir they could like compensate for the machine cost and the manufacturing cost later with the improved outputs, like lower machining time and higher productivity. So in the future, maybe this particular method will come into use. You never know, like it can for sure. अभी तो नहीं है इतना ज़्यादा इंडिया में, but आगे हो सकता है. So अभी I will just tell you about the research paper that I was doing. Okay, so उसमें मेरा research paper में क्या काम था. Okay, मैं आपको ज़रा research paper ही दिखाता हूँ. I have just saved this particular research paper over here. I had published a research paper on this particular conformal cooling only. उसका problem statement, अच्छा आपको screen दिख रहा है क्या ठीक से? अभी दिख रहा है स्क्रीन? हाँ. तो बेसिकली इसमें क्या था कि I had been given a task to reduce the warpage in this particular kidney tray. Okay, ये kidney tray था. Kidney tray क्या है कि kidney tray is used basically for as a container for putting your solid tissues, blooded cottons and वो सब. तो एक पर्टिकुलर किडनी ट्रे था एंड यू वांट टू रिड्यूस द वॉर्पेज इन दिस. अभी वॉर्पेज क्या होता है? वॉर्पेज जो ज्यादा होता है वो कॉर्नर्स पे आता है, इसके रिम्स पे, जिधर आपका पार्ट जो है वो अभी इधर क्यों आएगा ज्यादा, क्योंकि इधर कूलिंग करना काफी सबसे ज्यादा मुश्किल होगा. इधर इधर नॉन यूनिफॉर्म कूलिंग विल बी वन ऑफ द ग्रेटेस्ट फैक्टर्स, बिकॉज नीचे का जो वॉल थिकनेस है ना, ये पार्ट का नीचे का वॉल थिकनेस, लाइक इनसाइड द वॉल थिकनेस इज मोर एंड ऑन द एजेस इट्स लेस. ओके, सो फॉर दैट ऑन द एजेस वॉर्पेज उधर ज्यादा आता है जनरली. तो उसमें हाउ यू कैन रिड्यूस दैट पर्टिकुलर वॉर्पेज, ऐसा नहीं कि सिर्फ रिम्स पे आएगा, ओवरऑल भी आएगा, but how you can try and reduce that particular warpage was my particular problem statement. Okay, basically in order to reduce warpage you need to have uniform cooling throughout the part. So ये basically CAD model था. ठीक है, ये CAD model बनाया वो part का, उसका runner system मेरे बनाया 10 mm size as shown before that. फिर what I tried to do ना कि मैंने ना उसको cooling additional cooling channels दिया, मतलब ऐसे straight drill channels. Okay, at a distance of 10 mm from the center of the cooling channels will be at a distance of 10 mm from the mold surface. ये जनरली रहना चाहिए कि दिस इज वेरी इंपॉर्टेंट कि अगर आपका डिस्टेंस जो है मेंटेन रहा तो आपका सही कूलिंग हो सकता है. like it should be as near to the mold surface cavity as possible or the part as possible. ओके, फिर ये कन्वेंशनल चैनल्स बनाए. कन्वेंशनल क्या है कि दिस, सो बेसिकली these are the kind of channels which are also made, but these are also straight drilled only, like they are linear only, more difficult to manufacture, but for simulation purposes I just made these particular cooling channels, conventional cooling channels. These are traditional ones, straight drilled and conformal. So I made these conformal on the SolidWorks plastic software, okay, which conform the shape of the part. If you can like really see this, these and this are almost same. Just इसमें क्या है कि these are actually conforming to the shape of the part. Inlet है, outlet है, and distance was also maintained from throughout the. इसमें क्या improve distance देखो, इधर से 10 mm है, इधर से 15 है, तो इधर से 8 है, तो they are not the distances aren't the same. इधर काफी they are conforming to the shape of the part. So I just studied what warpage will you get by applying these particular cooling channels on this particular mold cavity. Then I put all these input parameters of डाला उसमें. Okay, now the result are mainly results. Okay, ये results क्या आता है? So if you see this, सबसे mold, and also one more thing what I did, conformal cooling जो था ना, conformal cooling, मैंने एक ऐसे थोड़ा सा तिकड़म किया कि मैंने क्या किया, ये जो पार्ट है इसको मैंने थोड़ा वॉल थिकनेस है ना, वॉल थिकनेस ज्यादा रखा, लाइक अराउंड आई केप्ट इट अराउंड 2.5 2.8 mm, एंड इसका मैंने 1.8 to 2 mm रखा. मतलब आई कंपेयर्ड by keeping the wall thickness, this wall thickness a little bit higher, this is a little bit lower. Okay, and even this is around 2.5 and 2.8, 2.5 only, 2.5 2.8 इसका wall thickness है. And I reduce the wall thickness of this particular part and try किया कि क्या होता है conformal cooling से, क्या होता है. Original wall thickness is that much only, 2.5 to 3 mm, 2.5 to 2.8 mm ही है original, but मैंने एक try किया कि इसमें थोड़ा सा wall thickness कम करूँ और देखो क्या results आए. So what I observed was, I'll directly take you to the results only. ये सब है देखो, ये सब part cooling time, freezing time. So I understood like observe the parameter, freezing time पे क्या इफेक्ट आता है, वॉल्यूमेट्रिक श्रिंकेज पे क्या इफेक्ट आता है, वॉर्पेज पे इफेक्ट क्या आता है, वो सब. एंड व्हाट आई ऑब्जर्व ना कि ट्रेडिशनल कूलिंग सिस्टम में और कन्वेंशनल में देखा तो कन्वेंशनल में काफी ज्यादा आता है, काफी ज्यादा कूलिंग टाइम लगता है, मोल्ड टेम्परेचर आफ्टर कूलिंग बहुत ज्यादा है, फ्रीजिंग टाइम बहुत ज्यादा लग रहा है, श्रिंकेज भी ज्यादा है, वॉर्पेज भी बहुत ज्यादा है. In the conventional as well as traditional channels, both like they are almost similar, but conventional में काफी ज़्यादा है as compared, if you can just see observe the values. But in the conformal cooling system, you can see the significant differences. Part cooling time 13.49, 38.1 as compared to 41.48, 40.41, and warpage especially 1.414. And when I further reduce that wall thickness of that part from 2.5 to 2.8 to around like 1.822 mm, it's reduced so significantly. It's around 1.371. now all these things I did through simulations only. मैंने कुछ इंडस्ट्री में प्रैक्टिकली टेस्ट नहीं किया क्योंकि ऑब्वियसली इंडस्ट्री में कुछ DMLS वगैरह मशीन्स वगैरह नहीं है. सो मैंने सिमुलेशन से ही वो स्टडी किया एंड आई ऑब्जर्व दी सिग्निफिकेंट डिफरेंसेस. जो आपको कूलिंग टाइम मिलेगा वो सॉफ्टवेयर डेफिनेटली एक्यूरेटली प्रेडिक्ट करेगा. ओके, सो दिस इज द पर्टिकुलर कंक्लूजन कि कॉन्फॉर्मल कूलिंग से आपको काफी बेटर इफ यू नो आउटपुट्स मिलते हैं, वॉरपेज आपका रिड्यूस होता है एंड इट्स एन एक्सीलेंट ट्रेड ऑफ. यू नो, again if I take you back to that figure, why was conventional cooling taking so much, giving so bad results? It's because of the improper distances from the mold cavity as well. Either 10 है, इधर 15, इधर 8 है. In comparison to that traditional, it is just 10 mm from the mold cavity. So that is also one of the major reasons why conventional cooling channels were taking so much time and giving such wrong bad effects. Okay, so वही है. So this is the basic observation in conformal cooling. And as you rightly mentioned, like conformal cooling can be used further by mold designers if they find it effective or with further advancements in technology. जैसे CNC machines था, CNC machines पहले use नहीं होता था, automatics use नहीं होता, but after people understood the advantages of it, such improved manufacturing times, such lower manufacturing and productivity, such good surface finish, then they started using it. So it's always, you know, advancements in technology which helps you to use these particular new things, and that is the way you should always, you know, try and the industries should try and, you know, modify themselves if required. Obviously not everyone will do it, but it is definitely a thing which can be the boon in the future. Yes sir. So that was the research paper. And also you can now, what I generally suggest you, I'll be very honest with you guys, whenever you learn certain things, like you do an internship in an industry and you want to publish a paper, never go in a haste to publish a paper first. Try and, you know, learn the particular process, the core things quite really well, and पेपर तो आपका बाद में हो ही जाएगा. जितना आपका नॉलेज बढ़ेगा उतना आप खुद से आप डाल सकते हो पेपर में वगैरह, जो भी आपको डालने का है वो, you know. So always you should first look into doing all the core things, like learning the things practically, and not, you know, मेरे को पेपर करने का है, मेरे को बाकी कुछ फर्क नहीं पड़ता, I just want to do paper for the sake because बाकी भी कर रहे हैं and I want to put it in my resume. No, that should not be our approach at all. बाद में, like, people will ask you questions, तूने कैसे किया, ये कैसे किया है, वो कैसे किया है, you will be speechless in that and you will make a fool out of yourselves. So always, like, try and, you know, first learn the things प्रैक्टिकली. जो भी सीखने का है वो, अगर पेपर नहीं किया तो भी चलेगा, पर पहले ये सब करो कि आप प्रैक्टिकली क्या सीखते हो, क्या नहीं सीखते हो. अभी, like, if you want, you know, there are a lot of methods through which warpage or these defects are being improved. Maybe for Prachit, I don't know if you know about this, maybe, or people who know about injection molding and sort of things. In industries like L&T and other places as well, they use a lot of DOE kind of things, like design of experiments. Then they use a Taguchi method in order to optimize their warpage and to reduce it. Actually, even I was doing the particular optimization technique for reducing the warpage using neural networks and genetic algorithms, and I had applied it in my B project as well. But unfortunately, because I had to, like, where I'm working, I have to be like, I have to do that work, so I did not continue it. But industry में DOE, design of experiments, Taguchi method काफी use कर रहे हैं in order to reduce and optimize the warpage and shrinkage as well. तो वो भी आप देख सकते हो. And a lot of papers are as well. Papers आप क्यों पढ़ो बताए, papers हमेशा पढ़ो to gain your knowledge. इंडस्ट्री में क्या चल रहा है, क्या नहीं चल रहा है, वो सब उधर से आपको काफी अच्छा नॉलेज मिलता है. That way. So if anything, guys, you want to ask, please do let me know.
Like, can we get a copy of the paper? Like, I wanted to just refer it once.
Sure, bro. I will. It is open access actually. I will give you the DOI of this paper. Like, what you can do now is, like, if you can take the screenshot of this particular thing right now.
Okay.
Alan, sorry to interrupt you, Advait. Alan, you just what is the title? You just tell me. I'll tell you how to download the paper. Don't worry about it.
Okay, sir.
Otherwise, what you can do now, bro, directly go on Google Scholar and just type Advait Purav in that, ADVAIT PURAV, Advait Purav, and you can directly get my paper in that. It was published
Okay,
in the IOP Web of Science Scopus Index Journal.
okay.
तो हाँ guys,
Thank
और
you.
और आपको कुछ भी अगर पूछना है तो but yes, आपको कुछ भी अगर है ना तो just let me know.
Sure.
Also, what I can suggest you, okay, continue with your question. Tell.
Sir, sir, ये cooling पूरा fluid मतलब plastic it fills, then afterwards that cooling starts, or it starts from before only?
Yes bro, like कैसे होता है, पहले इंजेक्शन होगा, इंजेक्शन होने के प्लास्टिक फिल होने के बाद प्लास्टिक नहीं तो फिल होने के बाद the punch die will, which is a moving die, will mate with the female die and cavity die, and फिर उसके बाद वो फिल होगा, ठीक है, मतलब the plastic will take that appropriate shape, and फिर वो पैकिंग होगा उसमें, मतलब अगर मेल और फीमेल एक साथ है, एक दूसरे के साथ मेट हुए हैं, तो उधर फिर पैकिंग होगा, फिर उसके बाद ड्यूरिंग दैट आफ्टर द पैकिंग प्रोसेस टेक्स प्लेस साइमल्टेनियसली व्हेन द पैकिंग प्रोसेस इज गोइंग ऑन, कूलिंग होता है. Cooling is happening throughout your cooling channels, cooling pipes, as the water circulates in and out of the mold. Okay, so that is the process when the cooling takes place, and cooling को ना सबसे ज़्यादा time लगता है. It's around 70% of the total process. So like if your total cycle time in injection molding is around maybe 25 seconds, cooling will constitute around maybe 13 to 12 to 13 seconds of the entire process. 12 to 15 seconds you can say of the entire process. उसको काफी टाइम लगता है कूलिंग को, एंड इट्स द मोस्ट इम्पोर्टेंट थिंग एज वेल. वैसे बट अभी कैसे होता है इंजेक्शन मोल्डिंग में, कैसे होता है, आई कैन शो द पीपीटी में थोड़ा सा दिखाता हूँ मैं आपको. अभी आपने क्या किया, एक मिनट, हाँ, अभी आपने क्या किया, अगर आप अभी आपका है ये पंच है, ये कैविटी है, ओके, अगर आपने ऐसे इधर से प्लास्टिक फिल हुआ, ठीक है, और आपका मेट हुआ, ऐसा नहीं कि योर पार्ट विल कम थ्रू क्वाइट properly and as you desire it in the first trial. No, it will take a series of trials and series of mating for the part to come out perfectly. पहले ट्रायल में आपका पूरा पार्ट फिल नहीं होगा. it will take some trials, it will take some kind of mating continuous processes to like they fill that particular cavity completely. पहले क्या होगा, पहले तेरा unfilled cavities आएगा. आपने पढ़ा होगा defects में, maybe if you have studied casting or molding, there are a lot of defects like unfilled sections, uneven sections, flash defects, वो सब आते रहेंगे. But as you go on increasing your injection pressure, as you keep on doing the trials, keep on increasing the pressure and adjusting it, and so accordingly your mold will go on getting filled, and थोड़े मतलब 4, 5, 10 ट्रायल के बाद अराउंड whatever it takes your part will be filled completely. तो वैसे होता है वो.
Okay, sir.
Yes guys. हाँ, also what I wanted to suggest you guys one thing only, कि guys अभी भी ना रिसर्च पेपर जब पब्लिश करोगे ना, try and like literature papers भी अच्छे होते हैं, no doubt, but अगर आप कोई प्रोजेक्ट करोगे इंडस्ट्री में जाके प्रैक्टिकली और फिर उस पे पेपर लिखोगे ना, it's always better for you. The reason being कि and like whatever research whatever work you have done in the industry, put the same thing in your paper. Like जब आपको कॉन्फ्रेंस में पूछेंगे कि यार what is the practical application of this, have you really tried this practically, मेरे को actually पूछा था कि have you really done this conformal cooling in that particular industry. So obviously I told कि no, it was not possible because that particular industry did not have the machine with it, and so it was not possible to do it practically. But be honest to them. But जो भी आप करोगे ना, you try and do it yourself first in the industry. जब आप maybe higher education करोगे, ME करोगे, या maybe even now in your B project internship, I don't know if you have B internship, but whenever you are doing internship, तो वैसे.
Sir.
Yes, बोलो ना.
Sir, water flow laminar होता है कि turbulent होता है?
Yes, good question. The water flow is always turbulent, guys. Hurry, I forgot to tell you about this particular thing. I'm so sorry. So this was a particular mathematical equation. So I forgot to tell you only, which was, I'll be honest, I did not derive. This is not derived, but this is an equation which was like approximated through and through an equation which I have found in the paper. मैंने derive नहीं किया बिल्कुल, वो इतना नहीं है, इतना होशियार नहीं है, बट लाइक ये इक्वेशन जो है ये पेपर से उठाया था मैंने, मतलब नॉट एग्जैक्टली बट थोड़ा सा मैंने उसमें सही थोड़े से अप्रोक्सीमेशंस किए. आई शोड इट टू माय प्रोफेसर एज सुधाकर सर एज वेल कि ये चलेगा इक्वेशन, तो रोल चलेगा, व्हाटएवर यू हैव डन इज ओके. सो उसमें क्या किया कि आई पुट ऑल दीज इनपुट पैरामीटर्स थ्रू द actual results into it, like melting temperature and ejection temperature है, 50 degrees molar temperature है, like software में जैसे है, and I got the answer which got the answer for the cooling time. For the cooling time, okay, part cooling time. तो मेरे को उसका आंसर 20.67 seconds आया और सिमुलेशन के बाद 16.49 16.5 seconds आया. Honestly, if you put these values into it, you will get this particular answer only. So it was this. So मतलब इससे पता क्या चलता है, कोई एकदम बड़ी बात नहीं कि जो मैंने इसे कुछ डिराइव वगैरह नहीं है, डिराइव वगैरह नहीं किया है, इससे पता क्या चलता है कि व्हाट सिमुलेशंस यू हैव डन दे आर राइट, मतलब एज कंपेयर्ड टू द फॉर्मूला एंड जो सॉफ्टवेयर ने कंप्यूट किया है वो सही है. हाँ, कमिंग बैक टू योर क्वेश्चन कि टर्बुलेंट फ्लो क्यों होता है. टर्बुलेंट फ्लो इसलिए होता है ब्रो क्योंकि योर वाटर इज गोइंग इन एंड आउट ऑफ द पाइप्स, थ्रू इन एंड आउट ऑफ द मोल्ड. ओके, इट इज फ्लोइंग कंटिन्यूअसली थ्रू योर पाइप्स. So in that you cannot keep your flow laminar. Okay, अगर laminar होगा तो वो ठीक से cool ही नहीं होगा. Your water flow, that flow rate is 150 cc's per second, and it needs to flow like really fast and turbulently so that it cools that mold throughout. Okay, और mold में अंदर बाहर जा रहा है, अंदर बाहर जाएगा तो it won't be like a steady flow. It has to be a turbulent flow. So it is a Reynolds number 5000 रखा है, which is you must be knowing this. Between 2000 to 4000 it's laminar, and beyond 4000 it's 5000, it's turbulent. That is a turbulent flow is kept over here.
Okay, sir.
Yes.
Anything else anyone want to ask? No.
हाँ, ये मैंने आप दिखा सकता हूँ मैं आपको. ये ना मोल्ड डिजाइन था उसका, वो पर्टिकुलर किडनी ट्रे का, ये पूरा मोल्ड था उसका. इट्स अ 3-plate मोल्ड ओनली गाइस. 3-plate मोल्ड मतलब मैंने उसका डिटेल में नहीं बताया, बट 3-plate मोल्ड फॉर दोज हु वांट टू नो, इट इज बेसिकली कंसिस्टिंग ऑफ अ दिस इज द कैविटी साइड, दिस एंड दिस इज द पंच साइड, इंजेक्टर प्लेट. सो इसमें टॉप प्लेट, रनर प्लेट एज वेल एज कैविटी प्लेट होता है. ये जो आपका है, दिस इज द कैविटी, दिस इज द पंच. ओके, तो ऐसे वो होता है इसमें.
Okay. Yeah, anyone want to ask anything? No, I think. Yeah, Advait, thank you.
Yes,
thank
sir.
you for such a wonderful session. If anything is required, I'll let you know. Okay.
Yes.
Yeah,
And
even
also, if you have any queries, you can like take a screenshot of this. You can contact me on this particular number.
That's
I'm
nice.
welcome to you. Yes, sir. Also, एक जाते जाते मेरे को एक बोलने का है, कुछ थोड़ा like just a guidance to my all my friends कि ना like what I've observed and I wish to share with some of my juniors as well. कि online classes में क्या होता है, online classes में we always ना take it very lightly कि मतलब जो भी टीचर्स पढ़ा रहे, लेक्चर्स, सब्जेक्ट्स पढ़ा रहे कि यार मतलब वी कैन इतना इम्पोर्टेंट नहीं है, ऑनलाइन है तो क्या इतना, मतलब एग्जाम्स भी हम वैसे ही मूड में लिखते हैं. पर ऐसे मत करो. ऑलवेज लाइक व्हाटएवर यू आर स्टडीइंग ना, अगर ठीक है वो बोरिंग भी होगा ना तो भी ट्राई एंड गो. लाइक यू माइट नॉट बी इंटरेस्टेड इन ऑल द सब्जेक्ट्स, बट जिसमें आप इंटरेस्टेड हो